Good evening. Good evening. Is my voice audible to you? Yes, please confirm the voice is audible to you. Yes. Yes, right. Okay. Did I give any homework question yesterday? I am not able to recall. I'm not able to recall if there was any homework question. There was any homework question? No, there was no homework question, right? Okay. So let us solve this question, and it is asked on the WhatsApp, right? And I saw some answers, okay, and I thought that I should be discussing this question. So as we don't have any other homework question, we'll take this question, okay. So those who have not read this question before, now it's time. Read the question. Read the question. Read the question. Those who have not read the question, you read the question. Okay. So we have a ladder like this, okay, and the ladder has just weight 30 Newton, right? 30 must be the weight of the ladder. Then it is 26 meters long. That means this must be 13 meters, and this must be 13 meters. Okay. Then mu floor is 0.3. Okay, that is static one. Wall is smooth, so no friction at the wall. One end of the ladder is 10 meters from the wall. One end of the ladder, that must be the lower end, isn't it? Right. So this distance is how much? This is 10 meters. Okay. Now see the forces. See the forces. Listen carefully. See the forces. Okay. Now we will have normal reaction here. Let us call as NA, saying this point is point A. We will have normal reaction at the wall also. NB. Okay. And we will have the friction force at the ground only, because wall is smooth. Okay. So at the floor, we have the friction force. Now, please don't say it is mu into n. Is there any clue regarding that? There's no clue regarding that, right? Okay. So don't say directly the friction force is equal to mu into n. We have discussed this part. Okay. You just have to apply that. The same thing here. That if it is nothing of that 5 things mentioned, you shouldn't take it in mu into n. Okay. Now, what we are asked to calculate is to go for to check whether rod is in equilibrium or not. Okay. Now, one of the answer which I saw was something like this. The student who posted that answer, he calculated this angle theta, right? Let us say theta. So from the trigonometry we can calculate. He calculated theta. He calculated phi, because tan of phi is mu s, right? So tan of phi mu s is 0.3. Okay. So he calculated, he compared these two, and we know something like that if theta is more than phi, then slipping happens. But listen carefully, that concept is applicable for weight on inclined surface. Weight on inclined surface. You can't bring that concept here. Why? Because here is no weight. Okay. Now see, if I say this like this, that here no weight is there, no inclined surface, then I shouldn't be using any analogy ever, right? See, you compare the forces. See, when we discuss that now, we had this inclined surface, we had this block there, and see, we had this weight only there. So weight, normal reaction, and frictional force. But see how things are different in this case. Here we have 4 forces, right? So you see technically, you see the technical details, you see the force details, see the location of the forces. Now you can't bring that concept here. You should know what to do, and you should more know what not to do. Okay. Okay. Now again, come back to the question. Question is asking us whether the rod is in equilibrium or not, isn't it? It is asking us equilibrium or not. Now, what is the idea to check the equilibrium or not? Now, see, the idea is like this. See, the idea is like this. I can develop the idea in you, means I can make you think. Okay, so see, I take an example here. I put this block on the ground surface. Okay, I say that this block is 100 Newton weight. I say that mu s is 0.2, some other value. Then I will take some force here as 15 Newton. Let me say 25 Newton. Okay. Now tell me whether this block is in equilibrium or not. Tell me. This block is in equilibrium or not, and with explanation. With explanation. Yes, see this block not in equilibrium. No, it is not in equilibrium. Why? Because you see that how much is mu s into n? How much is mu s? 0.2. How much is normal reaction? 20. Sorry, 100. Equal to weight. So how much is this? 20 Newton. Now how much is the P? See, P is more than mu s into n. That is where the block will move. Right? Right. Okay. So basically what you did, you calculated how much friction force maximum is there and how much is required to balance this 25 Newton. We will need 25 Newton, but we don't have 25 Newton. This is the idea. This is the idea. Okay. So let's use that idea here. Now see what I'm going to find first. First, I'm going to find friction force required for equilibrium. How much friction force is required for equilibrium? That value I will find. And then I will compare this friction force with the maximum friction force available. Okay, let's do that. Now see from the diagram, see now I'm calculating friction force required for equilibrium. That means I'm free to use equilibrium equations. Okay, so if I use sigma fx0, then you see that NB is equal to friction force. Okay, then I will take moment at A. Moment at A. Okay, now see moment at A will go like this. 30 Newton will give moment in this direction, which is counterclockwise. So plus 30 into distance will be 10 by 2, 5. Then NB needs vertical distance. This vertical distance. Okay. Now see this vertical distance is going to be, if I call it as X, it will be, check it, root over 26 square minus 10 square. Now 26 square is 676. 10 square is 100. 676 minus 100 is 576. Root of 576 is 24. So X vertical height is 24. So this NB will give moment in this direction, which is clockwise. So minus NB is NB into 24 is equal to 0. So from here I can write that NB is equal to 30 into 5 divided by 24. Note that I'm not using calculator here. 6 into 5, 6 into 4, 25 by 4 is 6.25 Newton. Now this much force is required for equilibrium because this force we got from the equilibrium equations, right? Now let us see how much is maximum available. Let me just pull this down. Okay, now let us see how much is maximum available. Okay, now I will go for sigma Fy0 for equilibrium. Vertical equilibrium must be there, right? So miss, we're talking about vertical equilibrium. So Na is equal to how much? 30 Newton. 30 Newton. So how much is maximum friction force available? Maximum is mu into n. Mu is how much in the question? Mu in the question is 0.3. How much normal relation? 30. So this is nothing but 9 Newton. Now see that. As FA required is how much? 6.25 is less than FA maximum available. So what it means? It means ladder is in equilibrium. Ladder is in equilibrium. Let me zoom out. Yes, now see the things. Let me just bring this on this side. Yes, now see the things together. Okay. Are you asking me to solve some more questions, 27 and 25? Ask on the WhatsApp group. I'm posting answers there. Does friction at point B also? They have mentioned smooth wall. Here is the question. Moment can be taken if it is in equilibrium. Yes, absolutely. We assume equilibrium. And we calculated how much friction force is required for the equilibrium. Okay, so that much we first calculated. Then we calculated how much is available, and then we got the answer. Okay. Somebody post the WhatsApp link so that one of the students can see it. But in order to make her see, we have to decide some fact first. Now listen carefully. Yesterday, some students were asking that they want to see what is the answer of others or what others are commenting. They want to see. So I said that vertical height may be 10. Means one end from the wall is 10 meters. Okay, so the vertical end it's on the wall. Okay, now coming back again. Listen carefully. Yes, now question is, do you want to see what others are commenting? Okay, so if I will take a poll, so before I take the poll, I will clear the things. You want to see others comments, then your screen or that message will keep coming all the time. If you are not irritated by that, okay, then you say yes, and I will take a poll, and whatever the result is there, means we will go with the majority, no matter what the answer is, right? We'll go with the majority. I prepared a poll, so I launched the poll now. Answer this poll. I will keep it open for 1 minute. Within 1 minute, I will take the decision. Means whatever you poll it, from that we'll take the decision. We want to see the others' comments, yes or no. And see whatever the majority will say, we'll go with that. Why theta and phi concept is not applicable here? Because this is not a block on the inclined surface, right? We derived that for the block on the inclined surface. Ritika, you ask the WhatsApp link on this my number. I will send it from this. Okay, Pushpin is saying we are not getting notification of continuous message. Okay. Can you repeat that, sir? Which part? Okay, 95% of students voted. I will keep it open for 20 more seconds. If anybody wants to vote it, it's time. Now, whatever number of students are to vote, that won't change the result. Why block case is not applicable here? Okay, why block case is not applicable here? Because when we see on the top of the screen, when we saw that block case, there were only weight, normal relation, friction force, only 3 forces at one location. But here we have more cases, right? We have 4 forces. They are at different locations. Okay, so moment also has to be balanced here. Okay, now that's it. 90%. Now only 6 are to vote. Now we'll end the polling. Now again, I'm telling you that whatever is the answer, whatever is the majority, that we will go with. Okay. Okay. Here is the result. Okay, I'm sharing the result with all of you. Okay, so you can see that for 57-43 it is, and 57% students wants to see it. Okay, now accept it. Accept it. I'm saying 43% who voted otherwise, you accept it. Whatever is the majority, you have to accept it. Otherwise, if you were majority, others would have accepted it, right? So I'll accept it. Okay. Now I'm allowing you to see it. Okay. Now attendance can view others' replies also. Okay. Now don't see those 43 students, 43% students. You don't think otherwise. Okay. That's why I cleared in the beginning that majority. And believe me, that is not the important. That is not most important thing. The subject is most important thing. Okay. Can we go back to the subject? I'll stop sharing it. Okay. Can we go back to the subject now? Yes. Okay. Yeah. Now I'll go for the next question here. Okay. Read the question and post your answer. Read the question and post your answer. This is from GATE exam. This is from GATE exam. Or don't post the things on WhatsApp now. In the break or after the class, I'm not going to answer now. Where should I focus? WhatsApp or your class? Remove the poll result. Didn't I stop it? Poll result. I stopped it, right? It stopped. Yes, it is stopped. Yeah. Where the force is applied, if nothing else is mentioned, you can imagine that steel wheel on the steel rail, wheel on the rail, the load will come at the center only. Load will come at center only. Okay, if I show you diagram, the diagram will be something like this. Okay, now what's the answer? You must be doing something like, okay, now stop. Look at the screen now. You must be doing something like mu into n. Okay, mu you must be taking 0.3. Normal reactions should be equal to 500, right? And that calls for 150 Newton, which is absolutely wrong. Now, why this is wrong? Why this is wrong? Because see, coefficient of rolling resistance. Coefficient of rolling resistance. This is not the mu. This is not the mu. Coefficient of friction is mu. This is not the coefficient of friction. So what it is a different term. It is a different term. Okay. So let us see what it exactly is. Okay. Now see, we have this steel wheel or wheel. It is on this steel rail. Now see, even the steel rails seems like very smooth. They are not ultra smooth. There must be some roughness there. Okay. Now we have this 500 Newton load coming on it, and we have to find out how much this P is required. How much this P is required to start some motion, and that motion is rolling motion. That is rolling motion. Okay. Now we have solved a similar question. I'll show you. I just have to find it. We have solved similar question now. Or not this one. Not that. Just let me find it. Just finding it. Yes, this question. Value of P required for rolling motion, right? And this is the same concept here. Same concept here. Now see how that concept is same here. Now see this ground is rough. I will just show that roughness here. Again, I'm showing this roughness. Okay, and you see this. See this that. See this part is the roughness. I've just enlarged it. So this is nothing but enlarged roughness. Okay, now keep listening. Now see that if ever this wheel has to start rolling, it must start creating moment about this point, right? So let us say this point is point A. So to have the rolling motion, the net moment about A must be more than 0. Then only rolling will start, right? So what we will do, we'll work at a condition where net moment about A is equal to 0. Again, you understand this logic. We need a moment more than 0, but still we will work at moment equal to 0. That will give me some value of P. Let us say 1 Newton, 10 Newton, let us say 10 Newton. Now that 10 Newton is not going to create the motion because it is calculated from the equilibrium equation. So if you apply little bit more than 10, then the moment will start. That is how we solve the numericals. Okay, so we will use this equation. Ma is equal to 0. Okay, now from the question you can see on the right hand side 600 mm was mentioned diameter. I'll just take a little on that side. Yes, 600 mm is diameter. You can see some part of it, right? So if that is the diameter, then see this, that see this distance. Now see this distance is less than radius, but this part is enlarged roughness, and just imagine the steel rail, it is very smooth. So this vertical distance, if I call it as y, this is approximately equal to radius only, and the radius is how much? Radius is 300 millimeters. The roughness height is very small, right? We have just enlarged it to understand what exactly it is. Okay, now see the next dimension here. See the next dimension. So this dimension from center to this point where the moment is to be taken. Now see this dimension, this value is equal to 0.3, which is mentioned in the question. See, this is coefficient of rolling resistance. Now this is very odd to define a state distance like this, but unfortunately it is defined like that. This distance is called as coefficient of rolling resistance. This is how it is defined. Now we can't do anything else. Okay, now if it is like this, now we have to work like this. Okay, now if it is like this, then you see that if I use moment about, okay, it is already there, this equation already there, right? So if you take moment about A, this P will give moment in clockwise direction, so minus moment P into it, the distance is almost radius, which is 300. This 500 will give anti-clockwise moment plus 500 into the distance is 0.3 is equal to 0. Now from here we can write that, see, 500 by 300, that will be 5 by 3, 0.3 by 3 is 0.1, 0.1 into 5 is 0.5 Newton. See the options, answer is the answer. Option is the answer. Yes. Yes, now see the things. What will be unit of coefficient of rolling resistance? It is the same unit as the unit of other values. It is the same unit as the unit of other values. Like other value, other dimension is millimeter, so this will be also millimeter. It is 0.3 times something like near to that, only millimeters only. 0.3, even 0.2, like that. Millimeters. coefficient of rolling resistance is a distance. It is a distance. Okay. Is force P that small? Yes, it is very small. Just imagine that you keep a roller on the surface, hold the surface, and see how much less force is required to rotate it. Very much less, right? So same thing is there also. How can a coefficient be distance? That's how it is defined. That is how it is defined. It is a new term. It is total new term. It is total new term. That's why don't use this as a mu. This is not. It is not. Okay. Okay. Now let's go for the next point. Okay. We'll go for the last point of this friction chapter. Okay. And then we are going for the next chapter today. Okay. So this friction, the last concept we are going to see is the wedge concept. Okay. Now see, this is what you have seen. This is actually it is the thing which we use to like break that log or that wooden block. Okay. So this part is called as a wedge. So you see, it is something like a tapered object, and it is a light object. Okay. Now see, light, you might say that it is steel, so it must be heavy. See, it is light with respect to what it is used on. So it is very light as compared to the wood or this log it is used on. It is very, very light object. Now, what is use of it? It is used for mechanical advantage. Okay. Mechanical advantage, I will explain these things with the help of a numerical. Okay. So there I will prove that you need less force to do whatever you want to do. Okay. So let's go for numerical. Okay. This is a numerical. This numerical is or was asked this year, and this was asked in civil engineering subjects. Civil engineering, because they have syllabus something like friction and application of friction, and where is the application of friction. Okay. Now you read the question first. You read the question first. Read the question. Read the question. Okay. Now listen carefully. Listen carefully. Now see that this tapered part. See this this one which I'm highlighting. This is the wedge. This is the wedge. On this tapered part, we are applying this force P. Okay. And what is asked to do? Listen, understand that carefully. See, we have to move in upward direction. What can we move in upward direction? There block Q. So instead of lifting the block from down, we are applying force P on this wedge, and this wedge will lift the block. Okay. If we don't use this wedge, then we need force equal to Q, isn't it? Because Q is the weight, right? So we need a force equal to Q. But I will prove that if you use something like a wedge, you will need a force less than Q. Okay, that will be the wedge mechanical advantage. Okay. Now, how to solve the numericals? Very simple. It is the same concept as we use for multiple blocks. Here, two blocks are here. One is a block, another is a wedge. Okay. So when we solve the questions of the multi-block, we saw that we should go for that ability first, which block is going to move first. Now you tell me which block is going to move first. I'm waiting for your replies. Which block will move first? Answer this. Answer this. Okay, okay. You are saying that wedge, and you are giving the explanation that force is applied on it. Okay. Now listen carefully. Listen carefully. Listen carefully. Stop answering. Okay. If your logic is that wedge will move first, then your logic is wedge will move first because force is acting on it. Then I'm not going to buy it. Why I'm not going to accept it? Because I'll show you examples. Just let me find the example. See in this one. See in this one. See in the first case, P minimum case. In P minimum case, the force was upward, but still the friction was also upward. No? Second case, friction force is upward and friction is downward. So you have to find out what is the meaning of that force P, what it is there for. Okay, so for example, in this question, let me zoom a bit. In this question, you understand that the block Q needs to be lifted, right? Okay, now to lift the block Q, the wedge should first move towards left hand side, and then the block will go upward, right? That is why the wedge will move first. So what is the answer here? Answer is wedge. Now you will say that, sir, even you have told same thing in different way. It is the same thing. Still, it is the same thing. Absolutely the same thing. That the force acting on the wedge, so the wedge will move first. But I will show you example. The next example itself that logic will be opposite. Just wait for it. Okay. Understand the meaning. Or let us confirm it first. Let us confirm it. Okay. Now see, read this question. Read this question, and you tell me that out of these two blocks with weights 500 Newton and 1000 Newton, which block will move first? With explanation. You have to read the question first. Yes, Pushpan, very correct that the block will go up only when the wedge will move first, right? Here, which block will move first? Okay. Yes, very good, very good. See that. See what the question is asking you for. Question is asking you that you have to find P such that it will hold the system in equilibrium. The job of P is to hold the system in equilibrium. So why the system won't be in equilibrium if P is not there? What will happen? This 500 Newton will try to go down because of its weight. It will push this 1000 Newton towards left hand side, and to not to get pushed towards left hand side, we need force P. So the first motion is of whom? This 500 Newton. Then it will be followed by this 1000 Newton. So whose ability should be drawn here first? 500 Newton. Now see that even if the force is acting on 1000 Newton, that 1000 Newton is not the block who is going to move first. That is why I said that here you were telling me the logic that because the wedge is experiencing the force, wedge ability should be drawn first. That was absolutely wrong there. Okay, there might be question like this, that in this diagram also, that find minimum force P to hold the block in equilibrium. Okay, in that case, block will move first. Okay, get it clear, get this thing clear. Okay, because you are going to come across questions where otherwise things will be asked. Okay. Okay, now we have confirmed this, we should go for the wedge first, right? So we should start with the ability of wedge. Okay, now see the wedge. I have to draw it first. You might see that I'm using some light colors today. Why I'm going for light colors, you will come to know in some time. Okay, so this is a wedge here. There is this force P. Then from the ground, we will have the normal reaction. I'll call it as N1. Now see in the question that between surfaces, the coefficient of friction is 0.2. All other surfaces are frictionless. That means we don't have friction at this ground surface, and we don't have friction here also. Only friction available is at the inclined surface. Okay, so we don't have friction at the ground. Now at the inclined surface, the normal reaction will be first like this. That is called as N2. And now see carefully that direction of friction. Now see who is going to move first? Wedge. That is why we are going for the wedge ability first. Wedge will move which way? Towards left now, because force is towards left hand side. If the wedge is trying to move towards left hand side, the friction must be towards right hand side. So this is the friction on the wedge whose value will be 0.2 N. Now see that I am using wedge. I'm using friction as impeding friction because question is telling me that impending condition. So I am not using any different logic. Multi-block logic only is being used here, right? Now see the angles. Now see this angle will be same as that wedge angle, which is 30 degrees. Now this normal reaction is perpendicular to inclined surface. So the angle of this with vertical will be 30 degrees. Right, because it is perpendicular. Friction force will have angle with horizontal 30 degrees. So its perpendicular will have angle 30 degrees with vertical. Horizontal, vertical, right? Okay. Now in this question, I'm not going to write equation. Why I'm not going to write equation? I will explain that. Okay. So just I'm going to hold everything here. Okay. Now in this system, how many unknowns are here? Wedge weight is not mentioned anywhere, is it? It's not. So wedge weight is not part of here. Now see here everything is unknown. N1 is unknown, N2 is unknown, P is unknown. Everything is unknown. So we don't get answer here. So we have to go for another thing, right? So now another thing, there is only that block. So let's go for the pre-body diagram, the block. Video block. Okay. Now in the bit of log, let me draw it first. The block is there first. Okay, this is the block. Now see weight Q is acting downward. Weight Q, I'll just show it here. Okay, it's not weight of the block, it is external force, because both weights are negligible set. And this Q we don't have value because we have to find relation between P and Q. So Q will be like Q only. Okay, now see the next forces. Listen carefully. See this N2 on the lower wedge. At this point N2, internal forces equal and opposite. If that N2 was downward, now that same N2 here will be inclinedly upward. And see again, this angle will be again 30 degrees. Okay, now see that friction force was going through first quadrant. Now opposite to that will happen here. That means it will go through third quadrant. This is 0.2 and 2, and angle, its angle with horizontal is 30 degrees. Now see from this vertical surface 3, this contact surface, there will be normal reaction. There won't be any friction force. So there is normal reaction. It is called this as N3. Okay. Now whatever I'm going to tell you, listen carefully and understand that part. Okay. Now see the first ability. We need to find P. Now in this first pre-body diagram, if I use sigma fx 0, I'll get equation that say the equation P towards left hand side, so minus P, then 0.2 N2, this is N2, right? 0.2 N2 into cos 30, then plus N2 sin 30. This is equal to 0. What this is telling me that, it is trying to tell me that just get value of N2. So you will get value of P. So don't go for value of N1. Okay. Now it also means that from this ability, just go for value of N2. So don't go for N3. Don't go for N3. You don't have to get the value of N3. So N3 is horizontal. So if I use sigma Fy0, I can avoid getting N3. Understand these things. Now see, N2 vertical component will be cost component. So I will have N2 cos 30. Q is downward, so minus Q. This 0.2 is N2 is also downward, so 0.2 N2, and it's sine 30 component. Okay, this is equal to 0. Now from here you get N2 in terms of Q. In terms of Q, once you have N2 in terms of Q, now see from this equation we can write that P is equal to CP goes on the right hand side. I can take N2 outside. So what I will remain inside is sine 30, which is 0.5 plus 0.2 into cos 30. So once we know N2, we can go back to P, which is from that equation, which is N2 into bracket sine 30 plus 0.2 into cos 30. So you put that value of N2 here, and you will be left with P as a function of Q, and whatever that parameter as of some value into Q, and that value itself is our answer. Let me zoom out. You do this calculation and post your answer. Yes. Friction force due to N1 is not considered because question is telling that all other surfaces are smooth surfaces. Yes, only P by Q or P in terms of Q is required. Nothing else is required. So don't go for anything else. That's why I said that. Listen to me what I'm telling. Pushpendra, you are telling something. Can you confirm? Can you give me final answer? Wouldn't friction force move block N upward? No, it wouldn't. It wouldn't. Normal direction is pushing it upward. See the friction direction. Yes, post your answer. Post your answer. Vishal is posting 0.9. Not in terms of N2, in terms of Q. In terms of Q. We shall post your entire answer that there must be some digit after 0.9 also. Why taken P negative? Because P is towards left hand side. Smurtika, check it again. Vishal, check it again. 0.87. I was getting almost 0.91 something. Is anyone getting there near that? Even you are getting 0.87 also, that will be this almost same. Okay, most of you are getting okay. So I confirm with that. It is almost equal to 0.88. Okay. Now see the options. In the option, the nearest one is 0.9. Nearest one is 0.9. Now you first listen this part. Now see that to lift Q, we are lifting the Q. We are lifting the Q. To lift Q without wedge, directly you lift it. Directly you lift it. If you want to lift it, you need to apply force equal to Q, right? Okay. But if you use wedge like this one here, you need only 90% of the force, right? Okay. So that is the mechanical advantage. It is so much difficult to scroll down. Through the comments you are saying, I mean normal. Okay. There are some individual doubts, but I will keep them in the doubt clearing session. Okay. Why weight is not considered? It is not given. Read the question. Read the question. See where it is mentioned. See the third line. That weights of the wedge and block are negligible compared to forces. And understand that you are asking me questions whose answers are there in the question statements. You are not asking me technical questions here, direction of the friction force and all. So it shows that what you are worried about. And it also shows that we are not reading the question which I'm giving you time, which I'm asking you specifically. Tarun is saying that it is difficult to scroll down. Yeah, but that is now reality. That means 57% students say it is to be like that. Okay. Now this is today's homework. This is today's homework. Okay, take a screenshot. Take a screenshot. Take a screenshot. This is today's homework. Individual doubts for doubt clearing session. Doubt clearing session. Individual doubts. Slash. Okay. Individual doubts at last. Now again, I'm telling you people that don't worry about that situation that you have to scroll down or you have to go through everybody's comment. You don't have to. You don't have to. But that is the democracy. We have to accept it. Okay. Okay. Now in the friction chapter, one point is pending there. In the friction chapter, I will show that point first. See, it is this this screw jack, which is formally based. I'm going to discuss the concept and all, which is formally based. I will hold it for the last. Okay. Okay. Now, because there are more important chapters, needs more time to be discussed. Okay. Now I'm going for the next chapter. I'm going for the next chapter. Yes. Oh, this is our next chapter, and name is Truss and Frames. Okay, last year 2021 GATE exam, they added this frames also. GATE exam, these frames were also added. Otherwise, truss were there always. Truss was there all the time. Truss was there all the time. Okay, but frames were added last time. But last time, many few other points were added, like Lagrange equation and all. So last time they asked some questions based upon new topics, but not to everybody's topic. Okay, but I'm thinking that I'm expecting that there will be question based upon frames in this one. Okay, this coming GATE exam. Now, first I will go for the truss and then I will go for the frames. Okay. Now, here I change the background. I just want to try it. Okay, for this chapter. And to as the background is black, I have to go for the paint colors. Okay, to write it on. That's why I already selected all the paint colors, and that's why I had to use them on the white background also for the previous questions. Okay. Now, please don't say that again, sir. Go to white. Okay, let us try at least for this one. Let us try at least for this chapter, and then we'll see. Then again, we can have 4. Okay. Okay. Now, bring your entire attention to what I'm going to tell. Okay. Listen these things. Listen these things. Okay. And I'm sure that you will not learn trust like this anywhere else. Okay. Now let's start with simple things. Now see, this is rod AB. This is also rod AB. Okay. Now on the rod AB on the left hand side, in the first case, how many forces are there? 2 forces are there. How many forces are there? 2 forces are there. Okay. Now let me add some more forces here, like this. Like this. Let me do something here also, like this. And let us say like this also. Okay, so I applied more forces now. Okay, so this all of forces, let us say P1, P2, P3, P4, P5, P6. Okay, and now this rod is in equilibrium. Rod is in equilibrium. If the rod is in equilibrium, then we have proved this fact that this rod will experience axial loading only. We have proved this. I have proved this. We have proved this, right? This rod will experience only axial loading. Okay. Now this condition is called as 2 force members, which means that there are forces at 2 locations only. So the resultant of this P1, P2, P3 and the result of P4, P5, P6 will be along this rod only, will be along the rod only. Okay, for equilibrium, it must be like this. So forces are at two ends. Now, if you see the right hand side rod, see here, three forces are here, P1, P2, and P3. And now these three forces are acting at three locations. That is why it is called as three-force member. Very simple. If the forces are at two locations, two-force member. If the forces are at three locations, three-force member. Okay. Now we see here, this second case, rod is not axially loaded. Rod is not axially loaded. I can prove it simply here also, that if I take a section here at a distance x, at this distance, how much is a shear force? Shear force will be equal to P3. How much is the bending moment? Bending moment will be equal to P3 into x. Right? So these members are not axial loaded. Okay. So here bending is also available and shear is also available. So I will say that this is bending and shear forces are present in the beam. Beam is expressing that. In the beam is expressing this, bending is experienced and shear also experienced. Okay. Now next point. Okay. Now chapter name is truss and frame structures. We're talking about the structures. So structure means it must be in equilibrium. Okay. So let us see the difference between these. Now see here. I have taken a structure here. So see number of members. One. So this is a different member because this is a pin here. So from this end A to end B, it is not one member. It is not. These are two members. So then this is third member, this is fourth member, fifth, sixth, seventh, eighth, and ninth member. Okay. Similarly, I will have different members here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now focus on the left hand side first. Focus on the left hand side. Okay. On the left hand side, understand that or confirm this, that all the forces P1, P2, P3, they are acting at the joints only. All forces. It's not responding. Yes. All forces P1, P2, P3 are at joints only. Is it true for the second loading? See, for this P5 force is not passing through the joint, right? So it is passing through some point along the length of the member 6. So I will say that not all forces at joints. Okay, first case again. If all forces are at the joints, it is called as a truss. If not all forces are passing through the joints, then it is called as a frame. This is the difference between truss and frame. Okay. In frames also, you see that some of the forces are passing through the joint, but not all the forces. Okay. Now focus on the truss first. Now see, for the truss, as all forces are passing through the joints, you pick any member. For example, member 7. See, for member 7, whatever loads are there, those are at this end or this end. So you pick any member in the truss. For that member, the loads, whatever loads or the reactions, they are acting at the ends only. And see, these members are straight members. So we know that if a straight member is subjected to loads at the ends, then that that member will experience only axial loading. Okay, so I'll make a statement here that all members will experience only axial loading. Only axial loading. You see any book, in the books they will say that this is an assumption. They will say that this is an assumption, but we have proved this. I have proved this, that the member will experience axial force. Okay, come to this second side. Now see here. Now see if I take see this one member. If I take this member, see this member. Let me draw that here. If I take this member, which is member 6, see, for that member, all loads are not at the ends because P5 is acting somewhere along the length. Okay, so that member will be experiencing bending and shear. So I will write that member 6 is experiencing bending, and if you recall from your machine design, shear is negligible, so I will just write bending there. Okay, now what about other members? See, in the frames, the other members like member 7, member 9, member 8, other members, see, for other members the loads are at the ends only. So other members of the frames will experience only axial. Let me note it here. What other members are there? See, member 1, 2, 3, 4, 5, 6 is not, 7, 8, 9. These all are axially loaded. Only the member who will experience loads other than the joints, only that member will be under bending. Okay, now next. Okay, now see, axially loaded means it can be either tension or it can be either compression. It can be tension or it can be compression. Okay, and in exam we are going to have both the answers in the options, plus P, minus P. So we have to pay proper attention towards direction, whether it's tension and compression. Now what attention to pay, how to confirm that I'm going to discuss. Okay, so here our job is basically to find whether the member is under how much axial tension or how much axial compression. Okay, now as the members are experiencing axial loading, we can draw the free body diagram of the joint. So here, method of joint is applicable. But here you see that as this is a frame, we should go for method of member. So we have to take a member to draw its free body diagram. Now all these points I have summarized in these tables, the same points here. And method of section is always useful for any of the things. Okay, now this is about truss and frames. Let me go for the next point. Okay, now again this structure is here, and you see that in this structure, I can see members 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and you see that these two loads, they are at the joints. Okay, so we can directly say that, we can surely say that this is a truss system, isn't it? Because loads are at the ends. We are first starting with the truss. We will get used to truss. We'll solve all the things of the truss, and then we'll go for the frames. Okay, so here it is a truss. Okay, now listen. We are asked to do the analysis of the truss. Now analysis means what? To do the analysis means what? We have to find the axial force in each member. Analysis means finding axial force, in each member. That is the meaning of analysis. That is the meaning of analysis. Now, why to find it? Very simple. See, suppose if I take member 7, let us say the force in member 7 is S7. Now, see, it is axial load. So, if it is axial load, how much will be axial stress? Force by area. Okay. Now, see, if we know the stress, this stress must be equal to or less than yield strength for safety. So, this thing is used obviously for design. Okay, so whatever stress is going to come, that should be less than or equally yield strength. It should be less. It should be less. Equal to SYT is again dangerous. So it should be less than SYT. Okay. Now this is the purpose. This is the purpose to calculate forces in all members. But in exam, we don't have that much time that to calculate all the member forces. So what we will be asked is calculate force in a particular member. Okay, now let's go for the next point. Okay, now see this beam here. See this beam. Now see from the diagram, this support is a roller support. Okay, and what about this support on the left hand side? This is a fixed support. This is fixed support. Okay, and there is a force, let us say force P, let us say at the center. Okay, now see the reactions. At roller, we can have only one reaction. Now see, listen carefully. See the reaction of the roller is how the direction. See the roller circle. See the plane on which the circle is kept. So this is the surface or plane on which circle is kept. Now the roller reaction is perpendicular to that surface. Okay, so if I call this point as point B, we will have RB vertical only. Come to point A, fixed support can give you all reactions. So we need vertical here. That let us call this RA. Fixed support gives you moment also. Now this is MA here. Okay, now next point. Keep listening. See in the diagram, how many number of forces? See how many forces are there? So there is P, there is RB, there is RA, and then there is MA. Okay, then unknown forces. See the P must be known, right? We have to do everything in terms of P. So unknowns are reactions RB, RA, MA. Okay, now tell me equilibrium equations. Which equilibrium equations we can use? I'm waiting for your reply. Which equilibrium equations we can use? Yes, I'm waiting for your reply. Post it. Nitin, don't just say all three. Amaldeep, good. Deepak, good. Pushpendra, good. Alan, check it. Raja Gandhi, check it. Alan, no. 50% are wrong. 50%. It is like everybody. Yes, it is like everybody. Forces are there, no? So it is everybody. All three no. Listen carefully. Stop writing. Stop posting your answers. Listen now. Listen. Focus on the screen. Now see that and understand that we can use only these equations. Are there forces in vertical direction? Yes. So we can use sigma Fy 0. Are there forces in x direction? No, there's no force in x direction. So you can't use sigma Fy 0. Even if you try to use it, the left hand side is 0. So 0 is equal to 0 is no equation at all, right? And we can use moment equation. Now, how many equations? 2. How many unknowns? 3. That is why this system is called as this color is not visible. I'll take another color. That is why this system is called as indeterminate. We cannot determine all the forces. Okay, then how to solve it? You know that something like statically indeterminate systems can be solved with compatibility equation and all. Okay. Yes, we have to go for the deflection, and deflection means that is a compatibility condition. Okay. Okay. Now this is an example that you have more number of unknowns than the equation, so you have to call it as a indeterminate. Now come back to our cases. Come back to our cases. Now see, we are studying the types of truss systems. Okay, so let me take a system here. Let me take some simple system. Now, this will be very simple system here. 3 members. This is pin joint. This is a roller joint on the right hand side. Then there is this force P. Okay, now keep listening. Don't add anything. Just keep listening. Okay. Now see that I'll call this end as A, this as B, and this as C. So I have 3 members A, B, B, C, and AC, and see that these members are loaded at the ends only. For example, if I take this member CB, for member CB, external load is at C, force in member AC is at C. At point B, you will have the force in member AB and reaction B. Okay, so whatever forces are there, they are at the ends only. So first thing should be confirmed that this is a truss. Okay, now see, in this case I'm writing something. See, on the right hand side I'm writing this is M for number of members, J for number of joints. So for this example, how many members are here? 3 members. Which members? See, AB, AC, and BC. These 3 members are there. Okay, now this next value I want is small j, which is number of joints. So see, how many joints are here? 3 joints. Which 3 joints? A, B, and C. These 3 joints are there. Okay, now listen, listen carefully. This is a truss. So for truss, we can use method of joint. We can use method of joint. Okay, now if we use the method of joint, which means that forces are acting at a joint. Forces acting at a joint. Okay, now if the forces are acting at a joint, tell me at a joint how many equations or which equations are applicable. Which equations are applicable? Which equations, Sachin? Which equations? Which equations? Which equations? Which, very good, very good. Motion, moment is not applicable now, because forces are passing through one joint, so moment is not applicable. Okay, see, we can use 2 equations. Which 2 equations? Sigma fx 0 and sigma fy 0. I will show you an example that will be better. I have to show you the diagram that will not better. Just let me find it. Yes, now see here. Yes, okay. Now see here. One of the students asked this question on the WhatsApp group. This we have solved. Not question, we solved this question. Okay. Now see, in this diagram, at joint R, all 3 forces are passing through. So you can use sigma fx0 and sigma fy0. Moment cannot be used or should not be used because moment is not there at all. Okay. So how many equations are applicable here? 2 equations. How many equations? 2 equations. Okay. So for one joint, 2 equations. For one joint, I have 2 equations. So listen carefully. Keep listening carefully. See what I'm writing. Total number of equations. Listen carefully what I'm saying. Now see this diagram. See this diagram. In this diagram, how many joints are here? 3 joints are here. B, A, and C. If I can draw free body diagram at each joint, right? Because this is truss system. So how many joints? 3 joints. At any joint, if I go for at any joint, I can use 2 equilibrium equations, sigma f0, sigma fy0. So how many total equations are available here? 2 at A, 2 at B, 2 at C. So total are how many? 6 are available. So I can write that mathematically, that how many equations are available. Now see, it is 2 into number of joints. 2 into number of joints. Okay. Now next one. Next one. Okay. Now let me add that number of unknowns. Okay. For our example, see how many equations? 6 equations. Why 6 equations? Because 3 joints, no? In our example. Equations. Okay. Next, number of unknowns. Number of unknowns means whatever forces you want to find. Okay. Now see here, how many forces are here? Listen carefully. Forces. See, we have to find force in member AB. We have to find force in member AC. We have to find force in member BC. Okay. But in order to find this, we have to find the reactions also, no? Because reactions only will help you to get the values. Otherwise, all values will not be possible to calculate. So we have to calculate the reactions also. Roller support RB will be there. Then at a hinge, so 2 reactions at hinge, so RAH and RA vertical. These all are unknowns. So how many unknowns are here? 6 unknowns are here. So see here, how many unknowns? 6 unknowns. 6 unknowns. Okay, now out of these 6 unknowns, you see that the first 3 unknowns, they are nothing but number of members. 3 members, 3 internal forces. Okay, and then I'm calling these reactions as small c, which I will call as the constraints or reactions. Constraints or reactions. Okay, so here reactions are 3, members are 3, all are unknowns, that is 6 are unknowns. So generalize, I can write this equation as m plus small c. Please confirm, is it okay by now? Is it okay by now? Yes, right? Okay. Now see next point. See the next very simple point. Which color? White. Okay. Listen carefully. Now, if I say m plus not 3, m plus c is equal to 2 into j. M plus c is equal to 2 into j. Now, what is meaning of this? Meaning of this is number of unknowns are equal to number of equations. So this must be determinate, because we can determine, right? This must be determinate, right? This is also called as perfect. This is also called as stable truss. Okay, second possibility. Now suppose m plus c is more than 2 into j. Now see what is more here. Whether the unknowns or equations. See, unknowns are more. So if unknowns are more, this is indeterminate. This is indeterminate. Okay. So indeterminate means you have more unknowns. More unknowns means that you have more members. More members means it is more stable. Or stable. Okay. Now what is the third possibility? Third possibility is m plus c is less than 2 into j. Now see that you have less number of forces than required, so this will be unstable. Okay, now again, what is this term C? This term C is nothing but the reactions. So how many reactions are here? 3 reactions. Which 3 reactions? 1 of roller and 2 of hinge. 1 of roller and 2 of hinge. Now by default, listen this. If nothing about the supports are mentioned, then the by default supports are if nothing is mentioned, then the supports are hinge and roller. Hinge and roller. So suppose there is a system with both hinges or both rollers, okay, that should be specially mentioned or that should be shown in the diagram. If nothing is specified, then by default we have to take supports as hinge and roller. If we have to take the supports as roller and hinge, that means by default small c will be how much? Small c will be 3, because hinge will have 2 reactions and the roller will have 1 reaction. That is why you must have seen this. Now see this formula, m plus c will become m plus 3. So see that formula is put here in this image. Okay, now let me zoom out so you can see the logic. Yes, now see the things together. Just have a look how the things are derived. That formula is not like some empirical formula. Okay. Okay. Okay, now I'm going towards this, how to solve the numericals. I want your total attention. Don't do anything else. Means don't post anything until I ask it. Okay, and if I ask to stop, you should stop. So you listen everything I'm telling. Everything I'm telling. Okay, so I will start with the. I will start with. Okay. Yes. Now I'm starting with the first approach or the first method where which we'll use to solve numerical. So method of joints. Now again I'm telling you that we are first going to study the truss system, and then I'll go for frames. You can see the diagram also. See the diagram, there is only one load, this load P, which is at the end, right? So this is truss. Okay, even if I don't name it, it must be truss only. Okay, as it is a truss, every member is under axial loading. Every member is under axial loading. Okay, we can go for free body diagram at the joint. So this is what I'm calling as method of joint, or we can draw the free body diagram at the joint. Keep listening. Keep listening. Okay, now for this diagram here, it might be easy to say that member AC, this member AC will experience compression because the load P is compressing it. It might be easy. If it is not easy, it's okay. Don't use any logic. Again, I'm saying don't use any logic to identify whether it is tension or compression, because you are going to make a mistake, or in exam this simple diagram will never be asked. Okay, what you do is you assume tension, show axial force tension, do the calculations. If it comes positive, it is a tension. If it comes negative, it is a compression. That's it. Okay, so we'll go with this approach where we will show the tension. Okay, now recall from the first chapter that tension should be shown towards the other end. So in the member AC, if I have to show the tension at C, it must be shown towards A. Now see, this will be SAC. I'm not using the subscript T, TAC. I'm using SAC. T, if I use it means tension by default, right? That's why I'm using S. Okay, it doesn't matter whether you use S or T. I'm just using one of them, which is S. Okay. If I have to show the tension in AC at A, it should be towards C. Now see, this is AC. Then if I go for AB, this will be tension directions. Again, learn how to show these tensions. Any mistake here, your answer will be opposite. Then here also tensions in BC. This is SBC and this is also SBC. Okay, and now how many joints are here? 3 joints. Which 3 joints? A, B, C, 3 joints. Okay, let me draw the free body diagram for all these 3 joints. Okay, so I'm starting with the free body diagram of, let us say, joint C. Okay, so if I go for joint C, which is here, now see this force P, I can show it down, I think downward, transmissibility. Then this SAC, C at joint C, SAC is like this. Then this SBC. This is joint C. Okay, let me go for next joint. Let's go for free body diagram at joint B. At joint B. Okay, listen carefully. So at joint B, we have the reaction RB. We will have only one reaction because it is a roller joint. Apart from this, we have two elements there connected, PC and AB. So we will have forces. You can refer the main diagram also. This will be SBC, and then there is this SAB. This is FBD at B. Okay, let's go for free body diagram at A. Free body diagram at A. Okay, so if I go for A is a roller hinge support. So 2 reactions. One will be vertical, another will be horizontal. Now what directions, horizontal, vertical? You assume and directions. Don't worry about them. You assume and directions are a vertical. Okay. Now apart from this, there is this member AB. So this will also come there. SAB. Okay. And then this SAC. Okay. Now you first have a look at individual free body diagram, and then I will comment on it. Okay, see every joint and see the forces corresponding free body diagram. Understand this, and again say that we are showing the tension. We have assumed tension. So if the answer comes positive, then tension is correct. Otherwise, it is negative. Is it okay? Okay. Okay. Now listen carefully. Now stop doing anything else. Listen carefully. This is what the conclusion is, and this conclusion is going to help us in exam or in numericals. Listen carefully. Okay. Now the first point is at each joint, you pick any joint. At each joint, you tell me which equations are available, which equations we can use. I'm waiting for your replies. Which equations? No, don't tell me number. Which equations? Which equations? Which equations? Very good. That we had just discussed, right? So it must be fresh in your mind. See, we can use sigma fx0 and we can use sigma fy0. We cannot use the moment equation because forces are passing through one joint. Okay. See, one more thing. See that if at a joint, if there are 3 forces, then we can use the Lami's theorem also, right? Because Lami's theorem is applicable, but 3 forces in equilibrium. We can use Lami's theorem, but there must be 3 forces only. Okay. Now, how many equations? 2 equations. If there are 2 equations at each joint, we can use 2 equations at each joint. It also means that at each joint, at any joint, listen carefully, at any joint, maximum 2 unknowns can be found. Isn't it? How many equations you can apply? 2 equations. So if you can apply 2 equations, how many unknowns you can find? Two unknowns, right? So suppose in this diagram, if I ask you to calculate, the force in member BC, listen carefully. If I ask you to calculate force in member BC, now from the diagram, see that either you can go for joint C, which is this joint, or you can go for joint B, because at these both locations you have SBC. Okay, now tell me, out of these two, which one you'll go for and why? Which one you'll go for? Tension is internal force. Yes, very good. See, you should go for joint C. Why we should go for joint C? Because at joint C, this force P is known, na? External force, it is known. So how many unknowns remaining at joint C? 2 unknowns, and we can find 2 unknowns at the joint, right? But if you go for joint B, there are 3 forces, RB, SBC, and SAB, and at this moment all are unknowns. Your first find reaction or SAB, then only you can find SBC. Okay, so at a joint you can find only 2 unknowns. Okay, now the next question, listen carefully. Next point. To find SAB, see, to find SAB, either use joint A or joint B. This is my statement. Now let me discuss it. Now see, what is asked to calculate me? Force in member AB. Force in member AB. So see the diagrams, all the diagrams, and see that the force AB is in free body diagram of B and free body diagram of A. It is not there in the free body diagram of C, is it? It's not. Why it is not there at free body diagram of C? Because AB is not joined at C. Okay, so AB is connected to A and connected to B. That's why it is AB. So to calculate SAB, either you have to go for A or B. Which one to go for? That we are going to discuss. But confirm here that you have to go for either A or B. You can't go for any other joint, right? Okay. Now these things I have written here. Now see first thing. See the first thing. To find force in member AB, you have to go for either joint A or joint B. That's what I just discussed. Then how many equations are available? Sigma fx0 and sigma fy0. Hence, at a joint, maximum 2 unknowns can be calculated. Okay. Now is it okay by now? Is it okay by now? Yes. Okay. Now, after saying this, the first example I am going to give you where there is exception. So first I will explain the expression example, then I will explain the explanation, exception, and then I will explain also that why there is exception. So I'm first discussing the exception here. Directly. Okay. Let me just remove one of the. Okay. I'm just removing those numbers. Okay. Okay. Don't worry, miss, whether equilibrium is there or not. You don't worry. You just don't worry. Okay. Now, let me say this is joint A. Let me say this is member 1. See, up to this. Let me say this is member 2 up to this, and then this is member 3. Don't worry about the equilibrium at all. Don't worry. I'm saying. Okay. Now listen carefully. Okay. If I go for free body diagram of joint A. Free body diagram at joint A. So this is joint A. See the forces. There is external force P downward. Okay. And then how many members are there? 3 members are there. Which 3 members? 1, 2, 3 members are there. Okay. Now I am going to show the tensions. That's what we are assuming. We are assuming. So see, tension should be shown away. Tension should be shown away. So the tension in member 1 at A should be like this. This is S1. Then the tension in member 2 should be like this. This is S2. And then come on. Then S3 will be like this. Okay, and this is the joint A. Okay, now at this joint, P is obviously known, right? So at this joint, how many unknowns are here? How many unknowns are here? See, unknowns are all those S1, S2, S3. All these are unknowns here, right? So how many unknowns? 3 unknowns. I have drawn free body diagram for a joint, and for a joint, how many unknowns I can find? I can find only 2 unknowns. Okay. Now, even if this is the situation, luckily see that if I use sigma Fy0, if I use sigma Fy0, then see what equation we are going to get. S3 is upward, so plus S3. P is downward, so minus P, no other in y direction, is equal to 0. Therefore, I will write that S3 is equal to P. Now this positive value is coming, that means it must be tension. And see that we have got the force in member S3, even if there were 3 unknowns at the joint. This is the exception. This is the exception. Even I was saying that at a joint, you can get only 2 unknowns. So even here, even more than 2 unknowns, 3 unknowns are here. We are getting them. Why we are getting them? Because luckily, you see here, this member 1, this member, and this member 2, they are collinear, so no component of them will come in the direction of 3. That is why we were lucky and we got this one. So there might be some cases like this. Okay, now let me write the second equation here. Second equation. See, I'm writing for the same keyboard, so I will use it here. See, if I write sigma Fx0, see what we will get is S1 minus S2 is equal to 0. So this S1 should be equal to S2. Okay, so this force in member 1 and 2 should be same. Okay, now again I'm telling that even 3 unknowns are there at a joint A. We get one of them, that is S3 we can get. That is because S1 and S2 are collinear. No component of them will come in the S3 direction. That is why we got S3 here. Is it okay by now? Is method of joints okay? Okay. Again, I'm going to see whatever I'm telling here now, whatever comments I'm making, whatever conclusion I'm making, every conclusion I will be using when I solve the numericals. Because when we go for the numericals, we should know all these things, all these possibilities, minor things we should know. So it will be very quick to solve the numerical. Okay. Okay, let's me go for next one. See, again, I'm telling that I'm not answering everybody's individual doubts. Okay, so whatever is not answered, that is reserved for the doubt clearing session. Okay, and it is not at all like that. I am not answering your question and I'm answering everybody's question. It is not like that. It is not at all like that. Okay, and it is also not like that I'm answering only few students' questions. Obviously not. Obviously not. Okay. Okay. Now this is one method, that is method of joints. Okay, we saw how it is, and we saw its applications or disadvantages, and right. So we'll go for the second method. Okay, now we are going for this method, okay, and this method, let me just call it, yeah, it's feasible, right? It is method of sections. Okay, method of sections. Let me better to write it. Method of sections. Okay. Now, before I go for it, let me ask you a question. Let me draw a diagram here. Let me draw some different diagrams so that I can test you. Okay. Suppose this is a tapered element, small diameter at the left and right and more diameter. So suppose if I apply axial force P at both ends. Okay, now you tell me where is critical section. Critical section is a section where the stress is maximum. You tell me this answer with explanation. So where is it? Smaller end, bigger end, middle, anywhere, everywhere. With explanation, with explanation, with explanation. Okay, I think it is easy, right? That you are saying the smaller end. Okay. Oh, no, it is easy. That is correct. First, you must have checked this that. So you take different sections. You take any section. At all sections, the force is P only. Force is P at all sections. Force is axial, so you can write stress is equal to P by A. So stress will be maximum whenever the area is minimum, because P is same for all the sections, right? So where is that? This is smaller end. Answer is smaller end. One of the favorite question in state level exams. Okay. Now the question here is how to get this value P at each section. How to get it? How to get it? Post your answer. Post your answer. How to get how much force is acting at that section. You know it. I know that you know it. So post it. Post it. How to get how much is the force at a particular section. It is same at every section, but how would you explain it? Yes, you cut it and see one side, any one side, because both sides will give same answer. And yesterday also we saw that even the object is accelerating, it will give same answer, right? Okay, now idea is you want to know how much is the internal force you take a section. Now I will use that idea here. That same idea I'm going to use here. Okay, now this is a confusing thing, how to take a section and how to draw free body diagram. So what I'm going to do, I'm going to discuss all the possibilities. Okay, so before I go for the possibilities, let me first show the axial forces. Okay, again, truss. This is all axial loaded members, right? So let us say this is A. This is B this time. Let us say this is C. So axial loaded, I am assuming tension. So if I assume tension, the tension must be like this. We just discussed the same thing in the joints. I'm just making you practice this thing by saying it again and again. So I'm showing the tensions at each. I'm assuming tension. Equilibrium equations will correct it. Okay. So see, this is this time SAC. This is also SAC. This is SBC. This is SBC. This is SAB. And this is also SAB. Okay. Now I am going to take the section. Okay. One more thing. Let me show the reactions first. So see the reactions at joint C, we will have this RC. At joint A, 2 because it is a pin, so vertical and horizontal. So this is RA vertical, this is RA horizontal. Okay, now I am taking the section here. I'm taking the section. Okay, now let me take the first section and see the first section. I'm taking like this. So I'll call this section as section 1-1. Now listen how I've taken the section. Okay, see, section is not passing through the joint. That is the one rule. Second rule is, see, section is not stopping in between. Section is not stopping in between. For example, see, did I stop it here? Did I stop it here? No, it shouldn't stop there. The section should cut the system into two parts. For example, if I give you the cantilever beam, if I apply the load P here, and if I ask you that, how much is the bending moment at this distance X? Everybody will say that it is P into X. But while getting the P into X, you have to cut it. But while cutting, will you cut it like this much only, or will you cut total? You have to cut total, right? So cutting total means you make two parts. You make two parts. Don't stop in between. Go throughout. Okay. Make two parts. So similarly here, you shouldn't cut like this. You should go through. Okay, now come back here. Now see, in this diagram, after cutting, you have two parts. This is one part, okay, and this is another part. Now tell me that, are these two parts symmetric? Are they symmetric? Is X is equal to L by 2? Is X equal to L by 2 always? No, it is not. They are not symmetric. So if they are not symmetric, then you don't have to worry about the symmetry. That means you are not limited for a section which you have to cut the things in symmetry. It is not. See, even for this section also now, even for this section, it is not symmetrical now. So you don't worry about that at all. You don't worry about that at all. Okay. Now again, this example. See, after cutting, we will refer one side, either right or left. Which one to go for? Whichever is easy for. Here right side is easy because there is a force P. If you go for the left hand side, you will have reactions, so you have to first calculate the reactions and then you can use the left hand side. So whichever is easy, we'll go for it. Just like our engineering stress, simple P by original area, right? Not the instantaneous area. Instantaneous area means true stress. Instantaneous area calculations are difficult. That's why we don't go for it. We go for easy thing. That is why engineering stress. Okay. So here also, whichever section you want to go, you are welcome to go for that section. But whichever is easy, you go for that. That will simple thing, right? Okay. Now this is one of the section. Now we can have another section also, or we can take section somewhere other also. For example, see, I can cut it like this also. Now see, don't stop at in between, right? You continue. I can cut like this also. Okay. So this is again, let me call this a section 1-1. Okay. Now again, I'm not passing the section through the joint. That is rule. Okay. And you cut it into two parts. These two parts are not symmetric. Again, I'm telling you that you are not limited for that thing. You cut anyway, whichever you want to. Okay. So which way that thing is coming. Okay. Now next part. Listen carefully. Okay. So which section we are taking? We are taking section 1-1. Okay. Now after taking the section 1-1, how many parts are there? Two parts are there. Which two parts? Upper part and lower part are there. Okay. Now let us draw the pre-point diagram for both. So I will first take the upper part. Now see upper part only. See the upper part only after the section. So in the upper part, we have this joint B. So this joint B is there. Then we have that force P in the upper part. So force P. Then we have these two forces SC, these two forces SAB and SBC. These both are in upper part. These both are passing through the point B. So I should show just the way they are. So this is SAB and this is SBC. This is SBC. This is SAB. Now, and see, this is joint B. Now see that in this part, upper part, there is no other force. So this is the total this is pre-body diagram. This is the pre-body diagram. So this is the pre-body diagram of the upper part of section 1. Let me draw the, okay. Now see, in this pre-body diagram, do you have the reactions? See, those reactions RAH, RA vertical and RC, those reactions are not here. Can you tell me why? Can you tell me why? Why reactions are not here? 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 Because they don't belong to this part. Do they? No, they don't belong to this upper part, right? Reactions belong to lower part. So that's why they are not here. Okay. Now, yes, very good. They don't belong to this part. They don't belong to this part. Okay. Now let me drag this down first. Okay. Now we are going for pre-body diagram again. Listen carefully. Of lower part, and this lower part is because of which section? Again, section 1. There's only one section, right? Section 1.1. Okay. Now see what things are there. What things are there in the lower part? Okay. So one by one. So I will start with these two. See, this AB is AC whole AC complete there. So I will first show it here. This AC is totally there. Okay, with this as A, this as C. Now see the forces. See the forces. Listen, don't do anything else. This color is okay. So this is RA vertical. Then this is RA horizontal. Whatever it is I'm showing you. Then this is RC. Okay. Then there is this SAB. Then this SAC. System is slow. Then this is SAC again, and then this is SBC, right? So nothing else is right. See, force P is not here because force P belongs to upper part, and we are drawing for the lower part, right? Okay, so this is a pre-body diagram. This is the pre-body diagram. Keep listening, keep listening. Okay, now see, in this pre-body diagram, see these two forces. See this SAC and this SSC. These both forces are equal, opposite, and collinear. So they will cancel each other. They will cancel each other. So this diagram is same as if I draw another diagram. If I draw another diagram, which is same diagram, and from this diagram, if I remove this SAC, then it will be same thing, isn't it? Because from the left diagram, those both SACs, they will cancel each other. Equal, opposite, and collinear, and they will cancel each other. So even if you take any equation, sigma fx 0 or moment 0, they won't be there. So why to show them, right? So this will be the pre-body diagram. This will be the pre-body diagram. Okay, now let me zoom out. Okay, now you first see this. Okay, you see these things, that you see the section, then see the upper part, and in the main diagram, then see the pre-board diagram, then see the section, lower part in the main diagram, and then see the pre-board diagram. Don't reply to each other. That someone is asking the question, you don't reply. That is not your job. Okay, miss you do that in WhatsApp or somewhere else, not here, because you focus on your thing. You first understand. SSC will get cancelled because it won't come in any equation. It won't come in any equation. You write any equation, it will be cancelled only. Okay, Sachin, if you're not getting that, ask me in the doubt clean session. I will prove it there. Okay. Where these trusses are used, see the big halls are there. In the big halls, you see the upper roof structure. Lots of members are connected in triangular manner. Na? Those are trusses only. In bridges also we use them. Okay. Okay, now see, this is how the pre-body diagrams are there for the method of sections. Okay, now what we will do, we'll take a break, and when we return from the break, then I will discuss what are the details of this. Okay, so we'll discuss from the numerical point of view that which one to use, which one not to use, and all. Okay, so it's time for the break. So we'll take a break at 7:45. Just like we discussed, Naki, for method of joint, which points, some points we discuss how to use it and all. So similarly we'll discuss for method of sections also. That is after break. So we'll meet at 7:45. Hello? Hello? Am I audible? Yes. Okay. Now the first thing, tomorrow our class is from 2 p.m. to 7 p.m. Okay. Now some students are saying that they have another class of maths at 6:30. Okay. I will check. I will talk to the management. Okay. And if it is there, then our class will be up to 6:30 only. Okay. So that part I will take care. So and what then our class will be up to what time? It is starting before their class, right? So I will tell in the class. Okay. Okay. No need to worry about that at all. Okay. Okay. Now let's go back to our tradition. Okay. And I'm going to discuss one very important thing today. That is how to build the concepts. Very interesting or very important thing. Important I will use word. Okay. Listen carefully. Okay. Understand what I'm trying to tell. Okay. Now see, for your exam, you need two things. First you need is formula. Our exam is formula oriented, aptitude exam, right? And second you need concepts. Okay. Okay, now for formula, I already told you this how to work it out, right? I already told you something like that. You have to invest like 61 hour to 90 minutes every day, 1.5 hour. Okay, take 2 subjects every day, revise the formula, keep on doing it. You will get all the formula. Okay. Now, what about the concepts? Now that this issue I'm addressing here. Okay, listen carefully. Okay. Now, what I'm going to ask you or how to approach this. See, for your GATE exam, the most important material is previous GATE questions. This is the most important. Same thing is for ESA also. Previous ESA are the most important questions for you people. Okay. Okay. Now, like I told you that, or you must agree on this me that how many times you should solve it? See, minimum 3 times. Minimum 3 times. Minimum. I solved 5 times. I'm asking you minimum 3 times. Okay. Now, when you solve it for the first time, now see what you will do. Suppose you are going for, let us say, mechanics itself. So you will read mechanics and then you will solve questions. Now what else way is there, right? You should read first and then you should solve. Okay. Listen carefully. When you are doing the same thing for the second time, you're already done the first time. You already solved it, right? You read the concepts and you solve the questions. Okay. Now, if you are going if you're going to solve the same question second time, then don't read. Don't read. Directly go for solving. Directly go for solve. Pick the questions, solve it. Okay. Now I'm sure that suppose this second time revision is happening in June. Suppose in the June. Okay, still it's 2 months from here. So, or at least 1.5 months. So it is 2 months from here, and suppose it's happening in the June, and you are not exam ready. You are not at all exam ready, right? In the June, obviously not. Now, what will happen? You won't be able to solve. Obviously, right? You are not reading it, right? You are not reading anything. Directly you are picking the question and you are solving it. So you are not able to solve it, which is understandable, which is totally understandable. But what one extraordinary thing is going to happen, why you are not able to solve it is because you don't know how to solve it. That means you will have a lot of doubts. You will have doubts. For example, if you pick a question from the friction and you are not able to solve, you will ask me question. You will have doubt like, if there are 2 blocks, which block separate should be drawn first? Then how much friction force should be taken? Why it should be taken mu into n? You will have lots of doubts. And believe me, this is the best part. This is the best part. More the doubts you will have now, more concepts will come to you. More concepts will come to you. Like today's magic is tomorrow's science. Today's doubts are tomorrow's your concept. First, you should know what you don't know. Then only you will be able to see what you don't know, or what you will be able to clear your doubt. So if you are not able to solve, that means you are getting lots of doubts. So if you are getting lots of doubt now you read. Now you read it. Okay, so now once you go for the reading, now you are going to read the theory with doubts. You know that when that Meos into n to be used, you have this doubt, and now there's the answer that there are 5 cases. Then you realize, yes, means you struggled, and you now know the solution. Okay, now listen, keep listening. Okay, so this should be approached from your second time. This should be your approach. You don't read and directly go for the numericals. What you will get is doubts. What you will get is doubts. Okay, now third time you are going. So when you are going for the third time, again same story. You don't read and solve. Okay, so what will happen? At least I'm saying 60 to 70% question. See, in the second attempt, if you try to solve it, at least I'm sure that 30% you will be able to solve 30%, right? Because you have solved it once. Okay, so 30% will be solved. Second time, the number will increase to 60 to 70%. Number will increase to 60 to 70%. Okay, now if you do like this, not reading and solving it, okay, it will give you one very good advantage, that you will start thinking. That is very interesting also, and that is very beautiful also. That is why on the WhatsApp group, one of the students posted a question and he asked for the solution. I said that instead of asking for the solution, you ask for the ideas. I mean, how to check that equilibrium. Then lot of things will come, and then we will be picking up which one is a logical way there. Okay, now suppose you are solving machine design, MD, or design of machine elements. In that, one of the chapters is theories of failure. Most important chapter. In that, you have theories like normal stress theory, shear stress theory, distortion theory, strain theory, and total strain energy theory. Now, whenever you are solving the questions of it, and what you will do always, that read and solve. That is your approach. But whenever you go for this approach now, what you are going to do in that approach, read means what? The principal stress theory will say that sigma 1 is equal to SY divided by factor of safety, whereas sigma 1 is that sigma x plus sigma y plus that equation. So what you are going to do, you are not going to solve the question, you are just going to put the values in this equation. What you will do, you will simply look for out of these things what is not given, what is given. You will put values in this one, and you will get the factor of safety or whatever else is there. Okay, so you are not solving the question, you are solving that formula. You are solving that formula. That is why you must have heard many times that students are saying that I have solved it 3 times, 4 times, but still I'm not getting the marks. This is the reason. What is the reason? That you people are reading it and then you are solving it. So once you read it, you know the formula, you are solving it, you are just putting the values in the formula. You are not solving at all it. You are just solving that equation. You are not solving the equation. That is the problem. Or it is like this, that if you read the theory and solve it, your mind is already limited to what you have read. Your mind is already limited to those formulae which you have just seen, because you have just read. Okay, and then you will think from the point of that formula only, and that is not considered building. Okay, just open a book question. Okay, like dynamics question, you open it, read it, and you will understand that what things you don't know, and then read the dynamic series, then you will understand it. That is why I'm telling you every day what I will teach tomorrow. Like I told you that I'll teach Trust today, so you read little bit part, you see some questions, so that you will have an idea what things you don't know. Okay, so again I'm telling you that if you want to build your concepts, this is the best way. From the second attempt, third attempt, don't read and go for solving. Okay. forgetting the previous subject while focusing on other subjects. That's why I said you that formula thing should go on every day. Okay. Then I'm asking you that, see, now you should study 3 subjects every day. 3 subjects every day. So that the frequency of the subject will be more. So that the the amount you will forget will be less. Okay. Okay, let's come back to method of sections. We were here, right? Right. Okay, so let us, shall I start concluding here? Okay. Okay, now listen. Now whatever else is doubts, your for doubt clearing session. Okay, listen carefully. Listen carefully. This is what is the summary of this, or where how to use this exactly. Okay, now listen, keep listen. Okay, listen. See, if I go for the upper part, in the upper part, which equations are available to me? Sigma fx0 and sigma fy0. Which equations? Sigma fx0, sigma fy0. Moment is not applicable in the first part or upper part because all the forces are passing to point B. So moment is not applicable. But if I see the lower one, see, I have all 3 equations available. Sigma fx0, sigma fy0, and sigma m0, because forces are not concurrent. So in general, I will say, in general, how many equations are available? 3 equations. In general, I'm saying there might be specific case like upper part where 2 are applicable. In general, 3 are available. If 3 are available, how many unknowns I can find? 3 unknowns. Right? Okay. Now next part. Okay. Okay. Now listen next. Okay. Now see the section. See the section. See this section, section 1.1. It is cutting which members? This section 1.1 is cutting AB and BC. AB and BC. It is not cutting this AC member, right? Okay. So see the both FBDs. In both FBDs, you will have forces SAB, SBC are there. SAB and SBC are there. Okay. But do you have this SAC force? It is not there. Why it is not there? Because it is getting cancelled. Because it is getting cancelled. Now what it means? It means that if you take a particular section, and if you take particular section, if you draw the free body diagram, we will have forces in those members which are getting cut. We will not see force in the member which is not getting cut. I repeat again, this section is cutting AB and BC. That is why you see the both FBDs. In both FBDs, you have forces SAB and SBC. This section is not cutting member AB. That is why we will not be able to see the force in member AC. That is why I will say that which members are the members which are getting cut, those members only show the force. The members which don't get the force, which don't get the cut, they will not show the force. Is that okay? Is that okay? All right. Okay. Yeah. Now next point. Listen to the next point. Okay. So the members which are getting cut, only those members are showing the force, right? Okay. Now listen carefully. See, we want to find the internal force. Now from this section, which section? This section 1.1. Can we find the force in member AC? We cannot. Why we can't find the force in member AC? Because see that there is no force AC here, because it is getting cancelled. So I will say that from this section, which forces we can find? We can find SBC and SAB. We cannot find force in member AC. Okay. Why we are not able to find the force in member AC? Because member AC is not getting cut. As it is not getting cut, we are not able to see its force. Why we are able to see the force in member BC and AB? Because it is getting cut. In short, if you want to see or calculate force in a particular member, you have to cut that member. then only the internal force of that member will be able to we will be able to see that. Okay, so the guideline is, if you want to find force in a particular member, your section must cut that member, right? Is it okay by now? Yes, confirm it. Is it okay by now? Yes, someone confirm it. Is it okay? See, all these guidelines I have already typed here. I'll show you. All these types are typed here. Okay, I'm just first explaining one by one. Okay, okay. Now I can come back to this one. Okay, now see again. So we have to cut that member where we want to find the force. Okay, now see how many equations are applicable for free body diagram. 3 equations. As 3 equations are applicable, how many unknowns we can find? 3 unknowns. That is why we should cut maximum 3 members. We should cut maximum 3 members. Why this rule is there? Because those 3 cut members will show force that will be unknown, and then we have 3 equations. If you cut more than 3, then that will be a problem, because you might not have enough equations. So the next guideline is cut how many members? 3 members. Why 3 members? Because 3 equations are applicable maximum. Okay, there can be some exceptions, but 99% you have to cut 3 members. Okay, next, you should not cut through the joint. Why not through the joint? Because if you cut through the joint, suppose joint B, then where you will show force P, and you can't show P by 2, no? That is not logical at all, no? So that is why don't go for the section passing through the joint. Okay, now after taking the section, either side is enough, right? One side is enough, because that's same thing for this bending moment diagram also, right? Where did you go? One section is enough, right? So you refer any one side, left, right, upper, lower, as per your convenience, whichever will involve less number of calculations. Now all those things I have put here. All those things I'll read them one by one. See, to find force in member AB, the member AB should be cut. Then only we can find the force in that particular member. Okay, now only the cut members, whichever members we are cutting, they will only show the internal force. Non-cut members, no internal force. Okay, how many equilibrium equations are available? 3, x0, y0, m0. That is why you cut maximum 3 members. Okay, then section should cut the system into 2 parts, and these 2 parts are not required to be symmetrical. Okay, now this is going to be one quick method. This is a quick method which I will prove also, to find force in particular member. Okay, and the rest things are simple things. Rest things are simple things. Okay, okay. Now is it okay by now? Sometimes we do cut 4 members, that is exception, but 99% times we have to limit ourselves to the 3 members. If cutting 3 members is not happening, then only we'll think of otherwise. Okay, okay. Now I'll go for the next part. See, whatever methods are there, I'm discussing merits, demerits, and then I'll go for the numericals. Okay. Okay, now this is most important part. This is most important part in the Truss chapter, where I want again full attention. Okay, now there are 2 special cases. One of the special case is, which I'm numbering it, special case 1. Okay, and this special case is of 3 members. How many members? 3 members. Now let me first specify every detail of this special case. Now see, I'm saying the details, what details I want. Okay, okay. Now see, the first detail I want is, okay, 3 members at a joint. I want a joint where 3 members are connected. Okay, now see the diagram. In this diagram, you see, I'll show you the, see this diagram, see the members, okay, and see the joints. So for this diagram, I can take E, 3 members. I cannot take D because how many? 5 are here. I can take F, I can take G, I can take H, I can take C. So this first condition is satisfied these three joints. Okay. The second condition. The second condition. No force. I'll be more specific. No external force or reaction at that joint. There should not be any force acting at that joint. So these three joints we selected. So for these three joints, no force. So these three still joints are satisfying whatever I'm asking for. Okay. The next one. How many members? 3 members I want. Out of 3 members, 2 should be collinear. Any 2 should be collinear. So now this rule is not applicable at C, but this rule is still applicable at E. This rule is applicable at F. So this E and F still are competition, right? Okay. Now comes the conclusion. Now see, if all these things are satisfied, now see, the result or the conclusion or the direct result you can write is this result, that the internal force which we are calculating, the internal force in non-collinear member, the internal force in non-collinear member is 0. This is the result. You don't have to do any calculation. You don't have to use any method of joint, method of section. You can directly take this. Why to directly take that? I will prove. Now what you do, you write on this first. You write on this. Okay. So you give the title on the paper that special case 1, 3 members. Write these 3 rules 1, 2, 3, and then write the result. Once you are done, then I will prove this. You do it. Once you are done, post done, sir. I'll go for next point. Give the title, special case of 3 members. Oh, Omkar, you are done with writing. You write very fast. Okay, what is the third point? Third point is I want out of those 3 members, 2 members should be collinear. I will prove. I'll explain again. Don't worry. Okay. So you are done. Now listen. Now I'm going to prove it. I'm going to prove it. Okay. Now let me take joint E. I'm going to prove it. Let me take joint E. So I am drawing the pre-ball diagram for joint E. Okay. This is joint E. At joint E, I have 3 members: AE, ED, and EH. Okay. So the forces will be like this. This will be SAE. Again, we are showing the tensions. Then this is SDE. Then this is SEH. Right? No other force here, no other member. Right? Okay. Now, for this case, equilibrium is always there. So if I use sigma Fy0, then what equation we will have? See that in vertical direction, SEH is only there. So this must be equal to 0. This must be equal to 0. And see that at joint E, 3 members, AE, ED, and EH. See this member, then this member, and then this member. Out of these three members, which one is a non-collinear? EH is a non-collinear, and how much force is coming in that? 0 by equilibrium equations. And that's what you have written. That is what you have written here. Okay, so I just proved it, and as I have proved it, now you can use this result directly in the exam. You don't have to do the calculations. I repeat, you don't have to do calculations. Directly you can use it. Okay, now there can be one doubt here. Okay, what is the doubt? Sir, is this rule applicable only for the member perpendicular or any other angle? So what I will do, see, now this member is there. Now I will just take it inclined. Let us say inclined. Okay, so I will just say that if there is some angle, let us say theta, 30 degrees, 60 degrees, 45 degrees. Okay, so if I take like this for now, okay, then see the equation, vertical equation. So SEH into sine theta is equal to 0. There's no other force in that direction. So now sine theta, see, this theta is not 0 now. If that theta is 0, then SEH will be horizontal. It is not 0. So sine theta cannot be 0. So sine theta cannot be 0. So SEH has to be 0. So even if this SEH is inclined, not perpendicular, still this rule is applicable. Okay, now I'll come back here. Okay, so see, by this rule, I'm again telling you that wherever this rule, this special case is applicable, directly I can say that that particular member will experience 0 force. Okay, so I will also say here that EH member is 0 force member. EH is 0 force member because that member is not experiencing any force. Okay, now let me do further. Now see that I can use this same rule at joint F also. Everything is applicable. Now I don't have to do calculations, right? So I can directly say that this member FG member will also have 0 force. So I will add here. FG member is also a 0 force member. Now see the next thing, very interesting thing. Now see at joint G, now FG is a 0 force. So 0 force, that means we can simply ignore this. We can simply, it is like it is not there at all, 0 force. So if FG is not there, then at joint G, this special case is again applicable because 3 members, no external force, 2 are collinear. So I can use again result that this member GD will experience 0 force. So again I have next member. Which member? GD member. Again it is in the category of 0 force members. And you can understand here also that, see, if I go for joint H, now EH member has no force. So I can simply eliminate it. So if I remove it, then member HD will have 0 force. So see, this member is GD, and again I have HD member also 0 force member. Okay, in many exams we are going to ask this question that which members are experiencing 0 force. So this is how we can find them. Okay, so same rule I have typed there in the bottom. I'll just make it white color. Yes. Okay, is it okay? Can I go for the next one? Can I go for the next special case? How to ignore? There's no force. No force calculations won't have it, right? Okay, we'll go for the next one. Okay, I'll go for the next one. Okay, so this is a second special case, and this is about 2 members. This is about two members. Okay. Now first I will explain what the conditions I want. Okay. Now I want a joint with two members. Obviously, that is why it is two members special case. Okay, I'll just be a little bit more specific, that I want joint with two non-collinear members. Non-collinear members. Okay, now see the diagram. See the diagram on the left hand side. So out of these joints, whatever joints you see, which joints I can use? Can you tell me which joints I can use? There are how many joints? 5, A, B, C, D, E. So which joints I can use? Two members, non-collinear members. See, joint D we can't go because three members are there. No. See, we can go for joint B, two members. We can go for joint E also. So by this time we can go for joint B and joint E. This one we can go. This one also we can go. Okay. Now the second condition. Second condition. No force at that joint. No force at that joint. No force means no external force, no reaction also. Now tell me, now which joint is applicable? Now which one? Now see, we can't go for B now because there's a reaction. Nah, this is roller support. So we can only go for joint E. We can only go for joint E. Okay, so these are the only conditions. Okay. Now what is the conclusion? Conclusion is, if something like this is there anywhere, two members, both are non-collinear, then force in both members is 0. Force in both members, is 0 force. Okay. Now this is the rule. Now again, you give this title special case to two members, write down these two rules and write down this, what is the conclusion. Then I will explain the next points. Once you're done writing, post next, I will go for the next. You're writing very fast. Pushpin, what you are asking, I'm not getting. Put in another words. Okay. Okay. Now listen carefully. So as per this rule, see, this member will experience 0 force. This member will also experience 0 force because both are non-collinear here. And if I use the previous case, then I can say that this member will experience 0 force here. So here, how many members are experiencing 0 force? 3 members: AE, EC, and CD. Is that okay? Is that okay? Okay. Okay, Pushpendra is asking this, sir, when we cut the section, the way we are cutting, should it be straight line or it can be curved? It can be curved also. It can be curved. Okay, one of the students asked how member CD is 0. Now you apply the special case of 3 members. Nah? So see, everything is applicable here. At a joint D, no external force, 3 members, then 2 are collinear, so the force in a non-collinear member will be 0. Okay. 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 Now we have studied all the required basics. Now we will go for the numericals. Okay. And while going for the numericals, how to think for these numericals? This is the sequence in which you will think. This is the sequence. First point is you will think of special case, because 70% of the numericals are coming for the special case. 70% I'm saying. And in special cases, we don't have to do the calculations. We can directly write that the particular members are zero force members, right? So that will save a lot of time. Okay. Then if the special case is not applicable, or if the special case is not giving the required answer, then we'll go for method of joint. Now, this is a controversial thing here, that every other class or every other faculty will tell you to go for method of sections first. Okay, but I'm telling you go for method of joints. Okay, I know that method of joints is not going to help you in many numericals, but still I'm asking you, because if it helps in some numericals, then it is very easier than method of sections, because taking a section, drawing a bit after the section is a difficult task. So if method of joints is ever applicable, that is going to be very simple. That is why it should be second method. And if none of these work, then you go for method of sections. Okay, again on the rough paper, you write down this sequence, because when I solve the numericals, I am going to use all of this. Method of joint is not time consuming. Depends upon the member, which everything is coming in the numerical discussion. Okay, now shall we go for the numericals? Yes, right. Okay, now whatever you are written on the paper now, everything you will, I will tell you to look for, and you will see everything, because here in numericals, how to think is more important. Okay, there can be different ways of solving the question, but we have to do it in the minimum time, least time. That is my aim to teach you. Okay, now we'll go for the numericals, and everything which I will talk, you will listen. Okay, now I'll go for the first numerical. This is the first numerical of the truss. Okay, first you read the question, read the question, read the question, read the question. Read the question. Okay, okay, don't give answer, not important. Now see the rough paper. On the rough paper, you have written that what is the first thing to do? Special case. Now, can we apply special case here? Yes. Where we can apply? At joint C. Sorry, at joint L. Because no external force, no external force. Then two members are collinear, K, L, and LM, and one is non-collinear. So what our rule says that the force in this member is how much? 0. So I can write that from special case, SLN is how much? 0. And that is what is asked to us. So our answer is option A, 0. You see that within 5 seconds you got the answer. That is why you first go for special case. Okay, now let me comment some more things. Okay, now this is not required for this question, but still I'm discussing this. I should be discussing. Okay, now see, LL member 0 force. Now if I go for N joint N, and this joint, okay, now for this joint, vertical member is as good as not being there at all. So if I use special case of 3 members, then what I'm going to get? I'm going to get the force in member NK also 0. Force in member NK also 0. So see, the next result I can write here that the force in member NK is also equal to 0, which is not required, but still we should know this. Okay. Okay. Now see, I will add something more. Try to, okay. Let me add it and then you say whether you understood that or not. Okay, now if I go back to joint L, vertically 0. Now 2 are remaining. Which 2? See this. See this one. This one is SLM. and then this one is SLK. They should be equal, na? Then only they will balance each other. So I can write that the next that SLM will be equal to SLK. Similarly, if I go at joint N, I can write that SNM should be equal to SNO. Okay. Okay. Now, can I go for the next numerical? Every point here is a joint. Every point is a joint. Okay. Some students asking that how NK is 0. How NK this one. This one. How this one is 0. Now see that. See this one is 0 will confirm now that NM N L ln vertical ln that is 0 now. If it is 0, then it is as good as not having there. So if I go for joint N, then see 3 members are there. This member, and then this member. Okay, so out of these 3 members, one is non-collinear, no external force. So Kn is also 0 as per our first case. Okay. 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 Now see at joint K, 2 members are remaining because NK is 0. LK and KO. Both are non-collinear, but I can't use the special case here. Why I can't use special case here? Because at joint A, you will have reaction forces. Na? Special case joints doesn't, there should not be any force there. Okay. Now let's go for the next question. Okay, now this is the next question. This was asked in 2019 GATE exam. Read the question. And you first tell me, can we apply special case anywhere? Can we apply special case anywhere? If yes, tell me which joint and which special case. Which joint, which special case? There are 2 special cases. Good. Okay, now see that we can apply the special case of joint B. Special case of 3 members, which says that there should be 3 members, 2 collinear, 1 non-collinear, no external force. If these conditions are satisfied, then the force in non-collinear member, that is BC, is how much? 0. So let the first result that force in the member BC is how much? 0. First result, but we don't need this, but this will help us. Now, if BC force is 0, then simply remove it, ignore it, leave it, then go for joint C. Now, again, the special case of joint, special case of 3 members is applicable at joint C. So what we will get? We'll get that SCD is equal to 0, right? The second result is SCD is equal to 0, right? That's what the answer is required. So your answer is 0 Newton here. Okay. Now, if I continue further here, then I can apply special case at joint B. So what it will give? Force in member D is 0. I can continue further. The force in the member EF will also be 0. So how many 0 force members are here? 4 0 force members. Now see, within fraction of seconds, we are getting the answer. Okay. Now, can we apply any other? Can we apply any other special case anywhere else here? Can we apply? Okay. Now see, whatever joints are remaining. Now see what joints are remaining. F is remaining, G is remaining, and A is remaining. See, at all these joints, you have some force. Which force? Reaction or external force. So you can't use special case here. Okay. Now let's go for next example. Okay. Now this question was asked last year. Last year question. Okay. You first read the question. Read the question. Read the question. Don't solve it. Don't solve it. You are not ready to solve the numericals. I will ask you to solve particular questions, but not now. Not now. You first read the question. Just do what I'm saying. I'm making you ready. Just read the question. Okay. Okay. Listen carefully. Listen carefully. Listen carefully. Listen carefully. Okay. Now see how to think smartly. You are asked to calculate which members are carrying zero force or which are the zero force members. Okay. Now, before you start applying any logic, before you start doing any calculations, first you look at the options. Please look at the options. See that in all options you have this BF there. That means BF, even if you get non-zero force, it must be zero. So you should not check for BF. Similarly, you should not check for DS also. GC is in most of the options. Don't check it. Don't check it, because even if you conclude that GC zero force, you have to again go for some other one. Okay. So the forces which are not there in all options are these forces, these members. You look for this first. You look for this. This is how you should approach the questions. Okay. Now see, I have to check for S, C, D, D, F, G, or GH. So I will check for joint E. I will check for joint E. I will check for joint E. Now at joint E, roller support is there. Roller, we know that gives reaction. This reaction by the roller, I will call it as RE, which I should call like that only. We know that that reaction by the roller is perpendicular to the surface on which it is kept. Always. Okay. If this is the case, then you see that if I take, why should I take? This is angle given 45 degrees. This angle is given 45 degrees. As that angle is 45 degrees, this angle must be 90 minus 45. And how much is 90 minus 45? It is 45 degrees. Okay. Now I am going to draw the free body diagram at joint E. You will say that, sir, at joint E, we don't know anything. We don't know force in any member. We don't know the reactions. So why you are going? Listen, see, you calculate those things which are required. So let me draw the free body diagram. And I means you are not yet ready to make the comments. You are not yet ready to solve. I will solve few good number of numericals. Then I will ask you. Then I will ask your judgment. Okay. Now I'm going for joint E. Listen, just listen. Okay. At joint E, there is reaction RE like this. How much angle it is making with horizontal? We got it as 45 degrees. Okay. Then there is member EH. This member. Now see for this member. Sorry, I will use another color. Listen. See, this length is how much? This length is 1 meter. How much is vertical length? 1 meter. So how much will be this angle? This angle will also be 45 degrees. If this EH angle is also 45 degrees, then the force in that member will be collinear with HE, na? Or that reaction RE, because both angles are 45 degrees. Okay. Then there's another member ED. So that ED member force will be horizontal as the member itself is. Okay. Now see the next point. Now see that this RE and EH is along one line. So I will simply call it as x-axis. And then whatever is the perpendicular line to it will be another one, that will be y-axis. Okay. Now I will take net force in y direction 0. And how much is this angle? This angle we calculate as 45 degrees because those both lengths are same. Okay. So if I use sigma fy0 here, see the equation. SED sine 45 is equal to 0. SED sine 45 is equal to 0. There sine 45 is 1 by root 2. It's not 0. Then SED has to be 0. And now, like I told you always that once you get any one solution, look for the options. In options, D is only in option C. So option C is the correct one. I got my answer. I don't have to do anything else. This is how you should solve the numericals. This is how you should solve the numericals. Now see everything again. Okay, and I'm put that here that as the members BF and DS and DS, they are in all other cases. So you don't go for them. Don't even find them. Is it okay? Okay. I'm going to explain the other things also, but understand the way to approach the question in the exam. I'm going to explain the other things also, that how those members have zero force. That is coming, but understand the way to approach the questions in the exam. Okay. Okay, now let me discuss how the other members have zero force. Okay, so I will just take the diagram here again. Now listen. Okay, so what answer we got? We got answer option C. Okay, so C, let's start with the BF. So see, for BF, I can use the special case at B. So this is 0. I can use the special case at G. So this will become 0. I can use the special case at D. So this will become 0. This is clear, right? But the question is how this CD is 0. How this CD is 0, right? Okay. Now we just got that. We got that member D is 0, right? We just proved it. And see in this numerical, I told you that the force in member LM is same as the force in member LK. Similarly, the force in member NM is same as the force in this member. Or if I go back to the special case of one, special case here, if I go to this special case here, see joint E. Joint E, look at joint E. So at joint E, I have drawn the free-body diagram. And for this case, if I use summation fx 0, if I use summation fx 0, see what I'm going to get. I'm going to get that SAE is equal to SDE. Okay, so if I use that logic here, at joint D, the vertical one is 0, so SCD must be equal to SDE. SD is already 0, that is why SCD must also be 0. Is it okay? Okay. How GC 0? GC 0 because you apply the special case at joint G, na? Special case of 3 members. Okay. Okay. How SCD 0? I just proved it. I will do one more way. Okay. I will draw the free body diagram at joint D. Okay. So see the free body diagram. So see on both sides, these two members are there. So this will be SD. This will be SCD. Then the vertical is there. Vertical SDH will be there. Okay. Now see the first thing. If I use sigma Fy0, then SDH will directly become 0. That is how our special case is. Okay. Then if I use sigma Fx0, then see what we are going to get is SDE is equal to SCD. But SD we just got here. I did all those things, right? And I got that SD how much? 0. So this SCD must also be 0. Okay. Okay. Now again, I'm saying that if individual doubts, let me ask them in the let me answer them in the doubt clearing session. Otherwise, number of numericals I solve will be less. Individual doubts, I'm saying individual. Okay. I'll go for the next one. I'll go for the next one. Read the question. Read the question. Don't answer anything. Just read the question. You are not yet ready to answer. Okay. Okay. Now. Okay. Listen. Okay. Now you first tell me, can we use special case anywhere? If it is applicable, tell me where and which special case. You tell me first, please. Yes, special case is not applicable. Okay. Now we are asked to calculate force in 3 members, right? See this member, okay, see this member, and this vertical member. Okay. Now see, what is our next option? Our next option is to go for measure of joints. Now understand that to go for method of joints, we need angles, right? Because cos theta, sin theta, we are going to use. We don't have any angles here. So I will just hold it. Now, if we go for section method, after taking a section, I have to draw free body diagram. I have to write the equation. If I write the equation, I need the dimensions, I need the angles. Nothing is available to me. So I can't go by that way also. I need to think some other way. Okay. Now see how I will solve this question. Listen. I have to go for B and C, right? So what I will do, I will go for free body diagram at joint C. At joint C. Okay. Now at joint C, carefully see, there will be roller reaction. There will be roller reaction, which will be RC. I have not yet calculated because I will calculate only when it is required. Only when equation will include RC, then only I will go for it. Okay. Then and again you can calculate. You can't calculate here, right? Because you don't have dimensions. Okay. Then see the vertical member DC. Vertical members DC. So tension in that S DC or CD. Then this SBC. This is joint C. In this one, if I use sigma Fy, sorry, Fx. If I use sigma Fx 0, see what I am going to get is SBC is equal to 0. This is member C. So I got one of the answer. Once I get this answer, I will look for the options and see option C cannot be answered now. Is it okay? Okay. And you have to remember this configuration that at the roller support, if you have only vertical and horizontal members connected, then horizontal member will have 0 force. Is it okay? Okay. Now next, listen carefully. Now see, at this joint, I cannot get SCD because SCD will be equal to RC value, and then I don't know any of them, so I can't get the value. So I will go to the next joint. I'll go to the next joint. Okay. Now I will go for joint E. I'll go for joint E. You must say to me this, that sir, don't go for joint E. Why, sir, don't go for joint E? Because we don't know the force in this member. We don't know the force in this member. We don't know the force in this member. And joint method gives 2 unknowns. Here are 3 unknowns. But still I will go for it because I have told you that there is an exception. And in that exception case, if the remaining 2 members are collinear, then I can get the answer. I will apply it here, and to apply it, I'll go for free body diagram at joint E. Pre-body diagram at joint E. Now see the pre-body diagram. Let me draw it first. There are two members like this. At this joint they are connected, which is joint E. From the upward, that force P is acting downward. See, this is the force P. And then that EB member will also have force. Okay. Use this color. And this is S. I will write B. This is SED. And this is SEA. Okay. Now see, I need this SB we need. Okay. So we don't need those in collinear members. So what we will do, we'll take x-axis along the collinear members, and then the y-axis will be perpendicular to them. This is the y-axis now. Okay. We don't need that SED and SEA. So to avoid them, I should use sigma FY0. Okay. Now see, from the diagram, we don't know the angles also. So what I will do, I will assume this angle theta. Assume some angle there. Okay. If this angle is theta, then see, this angle will also be theta. And if I go for sigma FY0, P's cos component is acting along y, that is downwards, so minus P into cos theta. Similarly, SB will have cos component, that again downwards, so minus SB cos theta is equal to 0. Now see, minus cos theta will get cancelled, and from here SB will come out to be minus P. That is compression. Now see the options again. See the options. Now see, no option is including minus sign. So that means they want only magnitudes. I'm sure that they must. No, they are not mentioned like magnitudes, but they want magnitudes because they are not mentioning minus. And you see that B is which member? BE is A member. So A means in the options A, B, C, the first one should be A. So already option C is gone. So now option D and B are gone. Now you have option A as your answer. Okay, now see the things again. See all the things. Okay. Again, see, you first see some standard numerical, standard examples, and then you go for the solving numericals. We are just preparing ourselves. Okay, so once I am done with solving all the variety, then I will ask you to practice the questions. Not it now. You are not yet ready. Just like listen carefully. Just like SFD BMD chapter. SFD BM chapter. How you should solve the SFD BM chapter in the exam? Miss in any test or exam. See, you first should know that what are the standard cases, like simple supported beam with a point load, like a single overhang with a UDL. You should know the standard results, and then when you go in the exam, you should apply one of the standard result or some standard result part to that given question. That is how same thing is applicable here also. You should know the standard examples and how they are solved, and then you go for the question solving. There you will think, okay, can I use that trick here? Can I use that trick here? So you should know all the tricks first. Okay, now how to know the tricks? What I'm going to do, listen carefully. See, whatever the standard questions are there now, I am going to make one word file of the standard questions. One file, word file. In that word file, I will put all these standard question images in one page. So I will compress them. Okay, what you have to do is that one page you take a printout on A3 or A2 or even in A1 paper, big size, that like just like our drawing sheets. Take a printout, paste that printout in your study room, and like I told you, the morning session, morning task, that 30-40 minutes, When you get up in the morning, you want to do yoga, you want to do exercise, you want to brush. Okay, just stand in front of that drawing sheet, see the question, think how to solve. See the questions, think how to solve. So if you can answer those standard questions now, you can answer any question. That is how we'll ask you to prepare for this. Okay, so that file I will provide tomorrow because I need time to prepare it. Okay. Let's solve this question. Let us solve this question. Okay, post your answer. Post your answer, and by which method? This question was asked in GATE exam. So again, what is the approach? Approach is see you have written it. You have written it. Standard case. Okay, so you first apply standard case or standard example. Standard case is applicable. So yes, standard case is applicable here, right? So standard case is applicable at joint E. So that will give you this force 0. So SDE is equal to 0. Not, you don't have to worry about anything. You directly go for answer option B. Now listen carefully. See, most of the time answer is 0. Doesn't mean all the time. Doesn't mean all the time. Okay, so don't go for 0 blindly. We can use this special case at this joint also, right? So this is also 0. This is also 0. Okay. Now I will give you some homework question and then we'll stop here. Okay. Now this is a homework question. Okay. So in this question, you have to find how many number of 0 post members are here. So you have to name them also. Take a screenshot. Take a screenshot. Take a screenshot. Because there are 3 homework questions. 3 homework questions. Okay. Now same question almost. I will just shifted the force. Okay. Now again, this is homework question. Take a screenshot. Take a screenshot. Okay. One more homework question. Interesting homework question. Okay. Now see in this question, see the things here. See how many members are there. See 1, 2, 3, then 4, 5, 6, 7, 8, 9. 9 members are here, and all lengths are same. All lengths are same. All are same length, identical members. Okay. I'm asking you to find forces in these 3 members. 1, 2, 3. You can see them. Okay. Very interesting question. Solution is very, very interesting. So these 3 homework questions, and we stop here today. Tomorrow our class will start at 2 p.m. Up to what time it will be? It will depend upon the if there's any other schedule. Okay, so I will have what schedule manager. Okay, and that I will continue in the class. So tomorrow 2 p.m. we are going to meet. Okay, now we will start the documents. Okay. Yes, now you can start raising the hand. Shiva Raman.
Hello, sir. Can you hear me, sir?
Yes.
Sir, why the static coefficient of friction is always greater than the kinetic coefficient of friction, sir?
Okay. The question is why μs is more than μk, right?
Yes, sir.
Okay. And did you attend the last lecture where I discussed laws of friction? Were you there? Yeah. Now can you see something on the screen?
Yes, sir.
Okay. Now see, when there are 2 reasons for the friction. One is interlocking and another is the resistance from the projected surfaces. When the body is at rest, the body will have time to get interlocked. But when the body is moving, body has less time to get interlocked. So the interlocking intensity while moving is less. That is why the friction while moving is less. That is why μk is less than μs.
Okay, sir. Okay.
Yeah. Shravan.
Hello, sir. Good evening, sir.
Good evening. You one of the comment you said that you are not getting anything today. Let me know what you are not getting.
Not anything, sir. Not everything.
Something.
Today,
okay. Yeah. Ask me then which things you were not getting.
I'm confusing with this. This is a new topic to me.
Which topic?
Trusses.
Trusses. You are confused. Okay. So those who are listening and if you are confused, that is totally understandable. Now what you do, I will ask the management to upload the video as soon as possible. Okay, so and I will upload the notes right after the dinner. You see the notes and again see the video. Again see the video before coming to tomorrow's class. I will request them to upload as soon as possible. Okay. Okay. Now ask which things you didn't understand.
So could you please open the 2019 question, gate question?
This one, yes.
So in this question, there will be a reaction force at F, right?
F and G both will have reaction forces. Yes.
Yeah. If there is a reaction force, then how will be the Fe will be 0?
Fe is becoming 0 not from joint F but from joint E.
Oh,
Joint E.
It means if Fe is not equal to 0, but Ef is equal to 0. You are saying.
Say it again.
Fe is not equal to 0, but Ef is equal to 0.
No. Always SEF is equal to SFE. Always.
Then how it will be 0, sir?
Okay. Now your question is if you go for joint F. Now see, if we go to joint E, it has become 0. So it will be 0. If you go for joint F now, whatever reaction is going to come, let us say RDP is like this. Now that will be equal to this force in member DF.
Okay. The reaction force from the bottom, it will be vertical, no, sir?
C means I will erase it. See, it is a circle, so it is a pin, so it is a hinge, so 2 components, so that means the result will be inclined.
Oh, okay. Now got it, sir.
Take time. Ask doubt and think and understand. Okay. Again, I'm saying that you people are not ready to solve the numericals. I will take some 10 more numericals. Then you will be ready to solve the numericals. Okay. And you have to go through this phase where you are confused, because confusion means doubts. Doubts means concepts are coming. Okay.
And similar to the G point also.
Yes, same story for G point also. Yes.
Got it, sir. And could you please open that gate 2020 question? It's a little bit confusing that wait. That question. Yes, this question, sir.
Which part of this is confusing to you?
You consider that the roller end, right?
Yes.
The question is about where will be the member will be equal to 0.
Yes.
I got only BF and DH will be 0, and I didn't get the CD and D. How it will be 0?
Yeah. Okay, that's the answer. See, BF, GC, HD are 0 from
yes,
special
sir.
case.
Yes.
And I told you that don't go for them.
Right? But
Right?
sir, there will be a force at point C. Then how it will be 0? You said that if there is a point, if there is at a point, if there is a force, then it won't be 0. Okay.
Listen carefully.
Okay.
Member GC is 0 from joint G, not from joint C.
Okay.
Okay.
And similar to that last question, we are considering from the G point.
Yeah. Now your next question is, if GC is 0, then who is taking that force P? See, there are 2 more members, CF and CH are there. Na? So those 2 members are there to take the vertical force. Na? So the vertical components of CF and CH will take FP. Na? Yes. Okay. Now one more thing. Okay. Now see, let me take the question only because I don't want anything else to be there. Okay. Now see how I think. See, when I see a joint E na, that 45 degree, I see that reaction is 45 degree only. Na? Yes, sir. This doesn't need any rocket science, right? Yes, sir. Okay. Then this angle is also 45 degrees. Yes, these 2 are same. So yes, this means that these 2 are in same line. Yes, sir. Then there will be equal forces. They should be same. Then this force must be 0, na? Yes, sir. Right. Now this thought brought me to this method, that go for joint E, and you have to learn this. You are learning this. You are not yet ready. I'm saying again. Yes, sir. Okay. So whenever next time you see, and I will show one more example, similar example. See this example. In this example also, this reaction at C is vertical, and that member is also vertical. So the perpendicular member must have 0 force. No? Yes, sir. Yes. So that's what I say, that standard cases, standard results, you must have in your mind while you go for numericals. So one of the standard case you can apply this. Take time. Again, take time. It should take time. It should take time. It took a lot of time for me, so it should take equal time for you also. Okay.
Yes, sir. It will take time.
Yeah, but I'm sure that you will be very good in trust. Tomorrow you will understand that how good the things will be. Okay. Any other doubt?
No, sir. No.
Okay, we'll meet tomorrow then, 2 p.m. Okay. Varun. Varun, are you there?
Yes, sir. Good evening, sir. Hello?
Yes, good evening. Yes.
Sir, actually, I have doubted in yesterday's question. The question which consists of two blocks, W1 and W2, and the upper one block is connected by a thread inclined.
This
Question
one?
number two, sir. Question number two.
Yes.
Yes. Actually, sir, actually, I was watching the recording, and while drawing this video of W1, you told that we are considering this system if it was a total system FBD, then this 0.3 N2 and N2 will be equal and opposite, and they will cancel each other. So I didn't get that statement actually.
Okay. Now see the diagram. See the pre-bottom of W1.
Yes.
Okay. Then see the pre-bottom W2. Okay. Now in the W1 you see N2. Okay.
Yes.
In this pre-bottom you see this N2. Now see these two N2s are equal and opposite.
Yeah, they will exactly cancel each other.
Yeah. So if I go for total, they will cancel. Similarly, this friction also will cancel. No?
Yeah. Yes. Right.
Whatever internal is cancelled will get cancelled.
Yes. Actually, I was just thinking. I know that we know this point actually, but I was just considering this single diagram. That's why I got confused.
Yes. Now you can apply this anywhere before also. We have solved a lot more numericals. There also this is applicable.
Yes, sir.
Okay.
Okay, sir. No problem. Thank you.
Welcome. Akhil.
Hello, sir. Good evening.
Good evening, Akhil.
Yeah, sir. Can you go to that coefficient of rolling resistance question? First question.
Oh, yes. Just let me look at it. This question. Yes.
Sir, here if the coefficient of rolling resistance is the distance, then at point A there will be friction, no, sir. That because it's a rough surface, we didn't consider the friction there.
We are taking moment there. So even if the friction is there, the moment will be zero. Na?
Okay, sir. Okay.
We are taking moment there only. Na?
So, but the ball is rolling, so there will be no friction opposing it.
No. Don't comment it because you don't know the whole picture. When the rolling will be there, then you will understand how the friction is. But see, whether it is towards left, towards right, okay, but it is through A only, right?
Yes, sir.
And we're taking moment at A. So no matter how it is, its moment is zero.
Yes, sir. Okay, sir. And sir, one more doubt, sir. In Trusses concept, you gave this formulas, no, sir. M plus C greater than this all.
Yeah. Yes.
Previous question, sir. Before this one, you gave one cantilever beam. There were like 4. Yes, sir. Here we can find using moment, no, sir. If we take moment at A, then we'll get RB and P. We can do that.
Say again. Last
Like
segment.
if we take moment at A, then the RB will rotate it like anti-clockwise. Then in terms of P, we can find the RB because the reactions at A will be 0.
Wait. If you take moment at A, okay.
Yes, sir.
This MA will also come, no?
So, but sigma MA will be 0, no, sir?
No. Wait. See, sigma MA, okay, and MA, these are two different things. Sigma MA, this first means summation of moments at point A. MA means the moment acting at point A.
Oh, okay, sir. Okay, sir.
Take time. Think and understand.
Okay,
Listen,
sir.
think
Got
and
it,
understand.
sir.
Okay.
So there is one more moment at A.
It is
like
a fixed support. Take a pen in your hand.
Yes,
Hold the left end. Okay, and try to rotate the right end. Your hand will experience the moment. Your hand will give opposite moment. That is the moment. That is the moment reaction.
Okay, sir.
Take time to understand. Okay.
Yes, sir.
Yeah.
That's it, sir. Thank you, sir.
Yes. Welcome. Sagar Gusalkar.
Sir, I am audible.
Yes.
Sir, I have a doubt that what is the need of zero force member?
Okay, so your question is, if the member is going to experience zero force, why to have it there, right?
Yes, sir. If you remove it, will the structure will withstand or not?
The structure will stand. Only thing is they are provided in case some more some force which we could not consider has come. If something emergency comes.
Okay, means that member will experience stresses but not force. Means,
No. This is absolutely wrong statement. If something is experiencing force, then only it will experience stress. I'm saying that if in emergency if more force comes than we anticipated, okay, then those members are there.
Yes, sir. Right. Sir, I have a doubt in a previous previous lecture.
Okay.
On example number 10 means to pulley cross belt drive.
This one.
Sir, here the sir, here how the angle came 30 degree and that 240 degree means I am a doubt. 30 degree, how 30 degree came? I understand 180 degree, but not 30 degree.
Okay, listen. Okay. Now see, we need this angle, right?
Yes, sir.
Okay, so let me say this as theta. Okay. Now see, if I take this triangle, this A, this B, and this C, this must be 90 because the rope is tangential, right?
Yes, it is.
Okay. Then A to B is radius, which is 6. A to C is 12 centimeter. So if I see this angle vertical, this is given. Right side, right? So if I take cos of alpha, then it must be 6 by 12. No?
6 by 12.
Adjacent side by hypotenuse.
Yes.
Okay. So alpha is 60 degrees because cos 60 is 1 by 2.
Alpha 60 degree, yes, sir.
Okay, so alpha is 60 and see this angle 90 degree, no?
90 minus 60, okay, 30 degrees.
This is 30 degrees. So once you get one angle, others are same, right? Means here also it will be 30 degrees. Here also 30 degrees. This is also 30 degrees, right? Then
Sir, then how theta 3 will be 30 plus 30 means
because here this theta is this much only, this much, na? This total.
Okay, yes, yes.
30, 13, this 180.
Yes, got it. Okay. Thank you.
Yeah. Nisarga.
Hello, sir.
Hello.
First, in the wedge question.
Wedge question. I think we went for this question. Yeah, this one, right?
Yeah. So, sir, you said that the mechanical advantage, right? So the answer was that we have to use 90% of the force using a wedge.
Yes.
So what will be the value of mechanical advantage here?
10%.
Which is the remaining is the mechanical advantage. Right?
Yes. It is actually something like means it will be Q by P. So it will be like 1 by 0.9. I think it is 11%.
Okay. Sir, and in the rolling resistance part, here you have defined the distance between the point of contact with ground and the point of contact with the obstacle. So is this how we define rolling resistance, that the distance between these 2 points?
Yes, it is how it is defined.
Okay, so this is the actual definition.
This is the definition. This is actual definition. This is the way it is defined. Now means we can question it why like this, but we don't have people who have defined it like this.
Okay.
Maybe it is easier to calculate some way or measure some way, maybe, but we don't have those many details available.
Okay, sir.
Okay.
Thank you.
Yeah. Sri Tattaya Naidu.
Sir, good evening, sir.
Good evening.
My doubt is in special case 2. Could you go for special case 2, sir?
Just a second. Naveen, if you're listening, I'm giving you my number. You message me on WhatsApp. I'll send you the link. Tataya, you want to go for special case 2?
How the two forces in EC and EA will be 0, sir, I think.
Okay, so you want whatever the conclusion, so you want to prove for it, right?
Yes, sir.
Okay, so let me draw the free body diagram at joint E. Okay, so this will be SEC.
Yes, sir.
And this will be SEA.
Yes, sir.
Okay, now see here 90 degrees are there, so I will take generalized case like SEC like this, and I will take SEA like this. Okay, so I will this theta. So in this case, theta is 90 degrees.
Yes, sir.
Okay. Now, if I take sigma Fy 0, the equation will be SEA sin theta is equal to 0.
Okay.
So sin theta is not 0, right? So SEA has to be 0. Okay. So SEA 0. Now see, this has to be 0, right? Otherwise, who is there to balance it? No one else. So it has to be 0. I can put mathematical also. So if I write sigma Fx 0, I will have equation that SEC plus SEA cos theta is equal to 0. Right? Now here SEA is already 0. So this must be also 0. Right?
That sir, from downwards reaction will be get no, sir, from to E joint.
Reactions are there, but they are at E. Sorry, A. They are not at E, na?
But the effect, no, sir. The line of action is towards A, no, sir. AE.
No. That whatever effect is there, that will come through AE, but that reaction will not act at E. No.
Reaction won't act at E, sir. That's why.
The reaction will not act at E.
Okay, sir.
Okay.
Okay.
Yeah. Kushal.
Sir, good evening.
Kushal.
Sir, I have a doubt in previous year gate question.
Which miss the solve one or something else?
No, you give the question bank na in your Google Drive. Can you open this?
Which year question?
Sir, this is question asking mining.
No, where is that question from?
Sorry, in your Google Drive, there is a folder in a GATE 2020 all question in engineering mechanics. In that folder, there is a question.
Okay, we have to look at it first.
Question number 2.
No, it will take time to download. Send me on the WhatsApp. I'll answer from there. Okay. Okay, send me on the WhatsApp. I'll send.
Okay, sir. I have one more doubt. Actually, sir, मैं थोड़ा हिंदी में बोलूँगा.
You speak in Hindi. I'll answer in English. Okay.
Sir,
whoever wants to speak in Hindi, you are welcome. Only the answer will come in English because others are also listening. Okay. Yeah.
सर होता कैसा है अगर आप पढ़ने बैठो बहुत टाइम तक आप पढ़ते हो फिर उसके बाद में अचानक से कोई दूसरा सब्जेक्ट लेने बैठ जाते हो तो जो पहला सब्जेक्ट रहता है जो पढ़ रहे हैं उसका बहुत सा पार्ट स्किप होता है फिर ध्यान में नहीं आता सॉल्व नहीं कर पाते या फिर कभी कभी कुछ नया देख लिया जैसे मैं कुछ ईएम पढ़ रहा हूँ और अचानक से मैंने थर्मोडायनामिक्स पढ़ लिया क्या यार ये तो बहुत हार्ड है तो ये भी करना चाहिए तो उस केस में होता है ना कि यार ये भी पढ़ना है ये भी करना है तो टेंशन आता है पैनिक हो जाता है इंसान तो कैसे ओवरकम करें और उसका सेल्फ कॉन्फिडेंस और फोकसिंग पावर कैसे बढ़े?
Okay. So those who don't understand Hindi, Kushal is asking that, sir, when we are preparing one subject, then we are afraid of other subjects, even if we have prepared it, because at that time we are not able to recall the previous subjects. Okay. See, and this must be happening with everyone. Okay, and whoever this is not happening now, you people are not studying. Believe me. Okay. And okay, this must be happening with everyone. This must be happening. Okay, and this should happen, and this does happen. Okay, Now, this is why I'm telling you people that you increase your frequency. That means you go for 3 subjects every day. The one subject going on mechanics and other 2 more subjects. So if you go for more subjects every day, now that subject will keep on coming more times. Otherwise, just imagine that you are just studying one subject like mechanics, then this mechanics will come after 1 month only. By the time after 1 month, everything of the mechanics will be new. First thing. Second thing, start doing that formula revision. Start doing that formula revision. 2 subjects every day. Now, initial 2 months will take to understand the formula. You have to continue it up to the end of the exam. After 2 months, once you have remembered all the formula, what will happen, Kushal or everyone, that you will start recalling the concepts. For example, if you write the formula m plus c is equal to 2j, you will start recalling why that m is there, why that c is there, what it means, what then you will say that why 2j is there. 2j is there because there is 2 equations available for a joint. Then why there are only 2 equations available? So that formula will help you to recall the concepts. Okay, and see, we are doing it every week. Now, every week subjects are coming, so you are revising it every week. Again, I am telling you that whatever this doubt is there now, this fear is there, then this will start disappearing. You practice that 2 subjects formula every day. Start doing it. I can give you 100% guarantee that after 2 months you will say that, sir, my 50 to 60% fear has gone. Start doing it. And there is no one day solution to this problem. There is no one day solution. There is no solution which will work in one day. Okay, it is like a corona care. You have to take it every day, every time. Okay. Okay, Kushal.
Okay, sir. Thank you.
Yes. Okay, I'll move next. Praveen Kumar.
Sir, good evening, sir.
Good evening.
Sir, running notes classes are not available in site, sir. How can I get, sir?
Okay, Praveen.
Classes are available, sir. Running notes, sir. Remaining classes, sir.
Okay, I think you did not join from the beginning. Okay. See this. This is the website. Okay. I'm posting it to one of the student so that it will be visible to everyone. Okay. And yeah, you can see the Nisarga's posted website. You click it, you'll go to the web. You will go to the website where everything is there. Okay. In case even if you don't get now, you just message WhatsApp me on this number. This is my number. You will get everything from there. And then there is a WhatsApp group also of us. I will add it to that group. Everything will be available to you. Okay. Hello.
Okay, sir. Thank you, sir.
Oh, yeah. Suraj.
Hello.
Suraj.
Hello. Good evening, sir.
Good evening, Suraj. Where are you from, Suraj?
I am from Odisha, sir.
Yes. Your sound likes over here. Okay. Okay.
Sir, please explain special case too, sir.
Special. Yeah. Yes.
Sir, audible sometimes actually, sir, I cannot understand, sir, what 2-0 taken EC0 and AE0 na.
Yes. You are not getting that part.
No, sir. No
Okay.
getting.
Okay. Now see the condition. There should be one joint.
Yes, sir.
At that joint, there should be 2 non-collinear members. Okay.
Yes, sir.
So see, at joint E, there are 2 members.
Yes,
now, this EC and AE member.
E member EC and EA. 2 members.
Vertical member. Right?
Yeah.
2 members. And there is no force now. If this is
there is no
satisfied, there is no force at joint E. Na? So if this is
Yes,
satisfied, then you can directly write the force in member EC and force in member AE0. Now, if you want to know how it is, I just explain that also. That see these equations. If you write these equations, now they will become 0. Okay.
yes. So keep another again diagram that I can understand better, sir.
Okay. One more diagram you want.
Yes, sir.
Just let me recall. There's one question in my mind, but that is also that's actually homework question, so I don't want. Okay, I'll take this. Okay, so suppose something like this is there. Suppose force P is here. Now see, if I see this joint, this joint,
Yes, sir.
let us say joint B. So
Yes,
for this
sir.
joint, these two members are non-collinear, and there's no force on this joint, no? So this both will be zero force members.
Zero.
Yes.
And that one जो P के जो opposite में सर कोलिनियर होगा ना सर वाला पॉइंट ये
वाला
है ना। हाँ सर, उसका जो पॉइंट जॉइंट सर जॉइंट
ये वाला।
हाँ सर, ये वाला कोलिनियर होगा ना सर।
हाँ,
ये तो जीरो होगा सर। हमको फर्स्ट केस
नहीं स्पेशल केस नहीं लगा सकते क्योंकि यहाँ पे फोर्स है ना।
ओहो हाँ नो ये राइट।
फोर्स होगा तो स्पेशल केस नहीं लगा सकते।
तो फोर्स नहीं रहा तो कैसे लगा सकते हैं सर इसमें? हाँ,
वही तो फोर्स नहीं होना चाहिए।
ओके सर, प्रॉब्लम 5 सर, प्रॉब्लम नंबर 5 सर। गेट क्वेश्चन, गेट 2020
गुड क्वेश्चन।
ये सर। हाँ सर, इसमें जो एफपीडी डी लिखे ना सर, जो निकाले एफपीडी का सर।
हाँ,
इसमें सर आप जो किए ना हॉरिजॉन्टल तो लिए फोर्स आरी, मैंने आपका जो रोलर का जारी लिए रिएक्शन ऑफ ई लेने के बाद जो आप जो एंगल के 45 एंगल जो बना है वाला साइन 45 सर क्यों वैसे उसमें तो कॉस 45 होना चाहिए क्योंकि तो उसमें तो एंगल हो रहा है ना।
ओके देखो ASED है।
SCD है हाँ सर।
और देखो हमको ये y एक्सिस के साथ एंगल चाहिए और ये 45 डिग्री है ना। तो इसको हमने डिस्कस किया था कि इसके साथ अगर 45 डिग्री है तो ये SED cos होगा ना ये। और इसको परपेंडिकुलर साइन होगा ना।
अच्छा
इसलिए ये y में साइन आ गया ना।
वो डायरेक्ट y डायरेक्शन और x डायरेक्शन है।
हाँ देखो सुनो तुम 2-3 बार ये पूछे हो। अभी थोड़ा
क्योंकि ना सर एक्चुअली ना सर मैकेनिज्म को तो डिटेल में नहीं पढ़ा तो इसलिए मैं समझ में नहीं आता।
नहीं देखो तुमने पहली बार पूछा, दूसरी बार पूछा, वहां तक मैं समझ सकता हूँ, लेकिन अभी थोड़ा तुमको प्रैक्टिस करना चाहिए ना।
हाँ सर, तो थोड़ा तो प्रैक्टिस होगा सर। एक्चुअली प्रैक्टिस हो रहा है कि बुक भी अवेलेबल नहीं है ना।
करो मैं बोल रहा हूँ
बुक्स भी सर अवेलेबल, बुक्स अवेलेबल नहीं है ना सर, इससे फिर दिक्कत।
अरे पर तुम्हें प्रैक्टिस करने के लिए क्वेश्चन चाहिए। मेरे वेबसाइट पे 100-200 क्वेश्चन है, वहां से क्यों नहीं कर रहे हो तुम?
ओके
है ना। और तुम्हें तो मैकेनिक्स क्वेश्चन बोल के गूगल में डालोगे तो वहां पे हजारों क्वेश्चन मिल जाएंगे तुमको। See, you are giving me excuse. I accept it, but who is at the loss? You are only at the loss.
हाँ लाइन वाली है सर एक्चुअली।
मतलब करो, सिर्फ तुम्हारे लिए नहीं बोल रहा, मैं सबके लिए बोल रहा हूँ। बच्चे मुझे बोलते हैं कि सर अभी तक बुक्स नहीं मिली। अरे हाँ मान है, लेकिन सर से पूछो, सर तुमको देंगे किताब, गूगल पे मिलेगी। सब मतलब गूगल पे है हमारा। करो, देखो करना है, कुछ भी हो जाए करना है।
सर इसमें जो लास्ट तो प्रॉब्लम सर बताए ना, लास्ट प्रॉब्लम सर जो
ये वाला
ये वाला सर। हाँ सर जो ये वाला सर, ये वाला तो आगे वाला सर, पीछे सर नेक्स्ट
ये वाला
जो। हाँ सर राइट। उसमें सर आप जो किए ना, उसमें जो अब जो P/2 जो किए सर, कैसे आप ऑप्शन लगा दिए सर। जो @ वाला किए सर, वो भी सेम कॉन्सेप्ट है ना सर, पिछला भी सेम कॉन्सेप्ट।
देखो पहले तो हम लोग मेंबर सी में 0 निकाला ना।
हाँ पहले 0 निकाल, समझ में आया सर। @ वाला
तो ऑप्शन सी नहीं आएगा उसमें, क्योंकि उसमें 0 है ही नहीं।
0 नहीं है सर, जो कि हमका है तीनों।
उसके बाद हमने निकाला मेंबर ए में P निकाला।
हाँ सर।
तो अभी देखो ABC में ये पहला नंबर है ना, तो पहले भी P, B और D में P/2 ही है, तो ऑप्शन ए में ही P है, तो हो गया आंसर आ गया।
सर और लास्ट क्वेश्चन डाउट सर, कोएफिशिएंट और रोलिंग रेजिस्टेंस क्या सर, इसका मतलब क्या होता है सर, कोएफिशिएंट रोलिंग रेजिस्टेंस?
उसका मतलब है डिस्टेंस है, डिस्टेंस. See this square, it means distance. Which distance? The distance which I have shown here.
तो उसमें सर दो तो फोर्स दिया है ना, हॉरिजॉन्टल वर्टिकल दोनों फोर्स है ना उसमें सर?
है ना? हाँ हाँ.
अच्छा, ओके, थैंक यू सर, थैंक यू.
Okay. Naveen. Naveen, are you there?
Hello, sir. Am I audible?
Hello. Yes.
Sir, I have a doubt on that. How we will take moment direction, sir, whether it is clockwise or anti-clockwise?
Okay. Suppose this is a point about which you want to take moment. Suppose this is a force. Okay. Now see, if you are the beginner, what you should do, you take your right hand, take the palm of right hand. Okay.
Okay, sir.
और जो thumb होता है ना, thumb part, you put it on A. Okay.
Okay, sir.
Then stretch your hand towards force. Okay. Then force is acting downward. Now you turn your right hand fingers downward, and now you see that how your fingers are turning clockwise. So this is direction.
Oh.
Right hand thumb rule. What you do, you go to YouTube and search their right hand thumb rule, see how it is applied, how it is explained. Now you apply it in numericals, you will understand clockwise and anti-clockwise.
Okay, sir.
Okay. Now see, everyone else knows it. It doesn't mean that they know it from the birth. They practice and they came to know. Now it is your time to practice. Okay.
Okay, sir. Okay, thank you, sir.
Joseph, are you there? Okay, you might be waiting for the last. Rajendra.
Yes, sir. Am I audible, sir?
Yes.
Sir, I just want to know the thought process of how have you taken it. Sir, would you go to the problem where the dimensions were not given? It was a gate problem in which dimensions were not given.
This one,
This one, yes, sir. Sir, why have you taken FBD at E? Like, what was your thought process for choosing it?
Okay. See, means I solve numericals, lot of numericals, and I have all the numericals in mind. That okay, but now what I thought here that if I draw a bit at E, okay, and if I take axis perpendicular to AD, then this B and P will have same component along BD, that cos component or sine component. Sine cos will get cancelled, and this B will come equal to P.
So would you repeat once?
If I take a bit at E, if I take axis perpendicular to AD, because I don't want that AD members there, then component of P will be same along this axis. If I say it is y-axis, so that component cos or sine will get cancelled, cos will get cancelled, cos will get cancelled, and B force will be equal to P.
Yes, sir. Got it.
Okay. Yeah. So that I applied here.
Okay, understood, sir. Thank you very much.
Hello, sir.
Joseph.
Sir, my doubt is in the beginning of the class, you solved a question of rolling an object, right? In which we are taken enlarging the roughness of that surface.
Yeah, it is on the screen.
Sir, in this question, can we do? So, what if we doesn't enlarge that roughness? We cannot take that moment, right? So, is there any other method to solve this problem?
No. There's no other method. This is the only method. Why I have to enlarge it? Because it is very small. See, actually, it will look like this. So you won't be able to see that point here. So you won't be able to see about which point it is rotating. That's why I have to enlarge. And I steel rail. Just imagine steel rail. It's very smooth, no?
Yes, it is very smooth.
Yeah.
Okay, sir. Thank you, sir.
Okay. Grishma.
Hello.
Hello.
Sir, in the propped cantilever beam,
Okay.
I did not understand the direction, how it is anti-clockwise.
Okay. See
And
this force is creating moment in this direction, external
clockwise,
force.
yes, sir.
And now to balance clockwise, how should be this direction?
In order to balance, yeah.
Right.
Yes, sir.
Just like your cantilever beam, no? See, cantilever beam you take. If you apply force like this, then the moment should be like this, no? Because this force is creating clockwise moment. To balance it, anti-clockwise moment should be there from the reaction. No?
Yes, balancing moment.
It has to. It is a reaction, so it should be opposite.
And the other doubt is, sir, in the last class, the second problem. The second problem.
Can you describe the question?
It is like one block upon other and connected with the string.
See the question.
Yes, yes, sir. Yes, sir. Sir, why didn't we consider in FBD of W1 weight of W2? Even MJ is acting on W1. W2.
Okay. Your question is why in this pre-body diagram we are not taking W2, right?
Yes, sir.
Okay. Now see the main diagram. W2 is connected with string.
Yes, sir.
So suppose W2 is it is 50 Newton given in the question. It is 50 Newton, right? So entire 50 Newton is not acting on W1 because tension is taking some of it.
Yes.
Some, let us say 10 Newton. So how much will be acting on W1? 40 Newton will be acting, right? That is why I always told you that I already told you that whenever you are using this kind of situations, you don't show the W2 acting on W1. You always show normal reaction, and the calculations will take care of it. If you show W2 now, there will be some numericals like this numerical where it will be wrong. It is true in 90% cases, but not 100% cases. But if you show the normal reaction, it is correct in 100% cases.
Yes.
Okay. Again, I'm telling you that some part of W2 will be taken by the string tension. So entire W2 is not acting on W1. That is why you should not take W2 reaction directly.
Sir, can you give the same type of example where we can't consider the
you want another example where we can't consider, right?
Yes.
Okay.
So it can be more clear for me.
Yes. Yes, see this numerical. See W2 and W1. Okay. See for W1 there is string connected. So W1, some part of W1, some weight of W1 will be taken by the string. The remaining will go on W2.
Yes.
Okay.
Yes.
Yeah.
And the other one is the truss problem, the last but one.
Numerical or something else?
Like P by 2 comma 0.
This one.
Yes.
This one.
So how do we get the force at DC?
How do I get force at BC? I drew the pre-body diagram at C.
Yes.
This is the pre-body diagram. Okay.
And RC is SCD.
Yeah, RC. Okay, now see if I have to write it clearly. Now see if I use sigma Fy0, then SCD is upward plus RC, right? This tells me that SCD is equal to minus RC, which means it is compression.
Yes.
Okay, but if I use sigma Fx0, then I get SBC 0.
Yes.
Because so that result I wanted.
Oh. Sir, I was asking like how do we get P by 2?
No, there's okay means there's no data given for that. Okay, and it is not required also. But still, if you want, see what the question means. See, they are trying to tell that these two are same. If these two are same, your load is at the center. If the load is at the center, this reaction at C must be P by 2.
Yes.
And you see on the right hand side now this is minus P by 2 because RC is equal to SCD. Now that satisfies the condition.
So the DB member is bisecting at the midpoint of AC.
Yes, yes, yes,
So
yes.
then it is minus 2.
Yeah,
Yes.
yeah, but there's no data to prove it, but it is not required also.
Thank you, sir. Got it.
Okay. Yeah.
Yes, sir. Thank you.
Boss.
Hello, sir. Am I audible? Hello.
Yes, yes, yes.
In a case where a body is moving with uniform velocity, where P is equals to frictional force, can we consider it as equilibrium? It is in equilibrium, sir.
Body moving with
uniform velocity.
We call it as dynamic equilibrium.
Dynamic equilibrium, sir. So, okay, sir. Then mu range is tan phi equals to mu, no, sir. Actually, the formula.
Say it again. What formula?
Tan phi equals to mu, the formula actually, no, sir.
Yes, yes.
So the tan ranges from 0 to infinity. Can mu be infinity? No. Okay, sir. Sir, and regarding the rolling friction, the first question, sir.
Wait. You are asking this question as tan is 0 to infinity, so you can.
Tan is equal to mu.
No. Let's say we have to use practical sense also. Right? I will give you an example. That means we shouldn't think like this also, like this. I will give you an example. Now say, if you take right angle triangle, let us say this is A, this is B, this is C. Then how much is C square?
A square plus B square.
Okay. Now what is Einstein's equation? E is equal to MC square, right? So how much is C square from here?
A square plus B square.
Now can I write this? C square is equal to E by M is also equal to A square plus B square?
No, sir.
So why not? Both are C square.
But because it is C, in here C is speed of velocity, but here C is a side.
Yeah. Right. Yes. You have to see practically the speed also, right?
Okay. And regarding first question, sir, in rolling friction concept. Sir, in here you did take tan phi equals to 0.3 and converted into the side, sir, 0.3 and 1.
I did not, I should not, because 0.3 is not mu.
Okay. So tan phi is equals to only mu s, only for static friction it is tan phi.
This is not mu. This is not coefficient of friction. This is not at all.
Okay, sir. For only for tan phi it is only static friction. For others it is not equals to tan phi.
This is not coefficient of friction at all, na.
I am considering mu s is equals to tan phi. That is on
mu s is coefficient of static friction. It is not every coefficient. Okay.
Only that mu s is considered as tan phi, but nothing other is considered as tan phi.
Yeah. That mu s is not any other coefficient. It is only coefficient of static friction.
Okay, but here can we consider a resultant between normal and the normal and resultant of friction force and normal can be the angle between
that can be considered anyway. That is considered anyway. But we don't know those things here, and that this point is not at all mu.
Okay, sir. Okay, sir. Thank you.
Yeah, that is all.
That is
all. Yeah. Okay, and one more thing, see, means the sequence in which I am asking you to ask the route, they see it is a sequence on that list. Whoever on the top, I'm asking it first. So it is not biased. Okay, so those who are getting last chance, your number is at last. That's why you're getting last chance. Okay. I hope you had a good day today. Sachin asking something. Sachin, if you are there, you want raise the hand. Sachin, are you there? Talk on the mic. If you are there. Yes, unmute and ask what's your doubt.
Sir, in rolling problem.
Say it.
Sir, why moment is equal to 0 consider moment is greater than 0, why not consider?
Moment is equal to 0, we are considering, and we are calculating some value of P. Let us say P is equal to 1 Newton. Okay, but we know that 1 Newton will give 0 moment. So what it means, it is minimum force. If we apply more than this, rolling will start. So we are calculating for minimum case.
Okay.
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 Yeah. Alan.
Hi, sir.
Hello.
Sir, I have a doubt regarding the GATE 2020 question that you have discussed. The last at the end we have discussed the GATE 2020.
This one.
Yes, sir. Yes, sir. Yeah, sir. We have taken that. We have considered that at point E, we have considered zero force because the RE is collinear with HE, right?
Yes.
But we have considered the special case 1 at that point, and in the special case we said that no external force or reaction at the joint.
No. Wait. We did not apply special case. I proved it. I wrote the equation. If I use the special case, I won't do any calculation. No.
Oh, it's not based on the special case. Okay.
It is not. Otherwise, I wouldn't have done any calculation. I wouldn't have drawn any diagram.
Okay, sir. Okay. Thank you, sir.
We use the special case in the previous numericals, right?
Okay.
And we did not write the equation down, right?
Okay, sir. Okay. Sir, I have one more doubt also. Sir, while yesterday we have done some problem, right? While I am redoing the problem, it approximately takes 10 minutes and all for solving the problem. How can we increase the speed of doing the problem, sir?
I will add one more question that what is happening? Where means
some problems are taking 10 minutes, some are taking just 3 to 4 minutes, but
yes. I'm okay. Miss, I will relate another question to this. Another question is students are saying that, sir, there is a lot of variety of questions coming. Okay. So and Miss, lot of numericals have a lot of different concepts. Okay.
Yes.
Like for example, in this question, you are drawing freeboard diagram at E, and you didn't discuss this in the special case. All right.
Yes, sir.
So you might be thinking that, sir, then how many different cases will come? Answer is no. In your GATE, out of 65 questions, hardly 3 to 4 questions are going to be different questions. Remaining 60 to 61 questions are going to be same questions. Okay. So you see these questions first time, new to you, you solve them again, they will become same. They will become familiar with you. Okay. So for 95% of the questions, you have to solve 95% of questions coming in the GATE exam, like 60 questions, they will be repeated questions.
Okay, sir.
So for example, in your machine design, is it done?
What? Yes, sir.
So there are eccentric loading cases, right? Weld, rivet, and threads,
yes,
right?
Sir. Yes,
so whatever you learned there, you don't have to solve a different question, eccentric loading. No, similar questions come. And if you see my website and machine design folder now, whatever types are there, I have covered there. So you won't get a different question. You will get a similar question with the different values.
Yes, sir.
Okay.
Okay, sir.
Yeah. And again, if you do things like this, that you just take in the morning session, if you do like what I told now, your thinking speed will increase. So that will like optimize what to do in the while solving.
Yes, I am thinking it fast, but the procedures are taking so long to complete. That's the problem, I think.
Okay, it is like this. There will be a lot of things where I will ask you to remember the derivation. For example, in machine design, clutch. There are two theories, pressure and wear theory, right?
Yes, pressure theory.
I will always ask you to remember the derivation. I will never ask you to remember the formula, because formula will confuse you. Okay.
Yes,
but you will say that, sir, how to remember how to do derivation. Okay, now you see that if you do that the derivation for the first time, it will take 10 minutes. Next time, 9, 8, 7, 6, 5, 4, 30 seconds you can do the derivation. So if you are able to do the derivation 30 seconds, then you don't have to remember the formula, which is already confusing.
Yes, sir. Okay. Okay.
Do it again. Do it again. Do it again. Do it again. That's how we have remembered. That's how we teacher have remembered it.
Okay,
it is
sir.
not like we know everything. No, we have taught this subject for n number of times. That's why we know answer like 3.2343.
Okay, sir. Okay, sir. Okay, sir.
Okay, yeah.
Sir,
We
I
are
have one
just
more.
senior students. We are not teachers. We are just senior students.
Yes, sir. Okay, sir. Sir, I have one more doubt. I have already asked this yesterday, but Lami's theorem problem. We have said that homework question of day before yesterday. Can we
Yes.
solve it through Lami's theorem?
Okay. See means I will show you. Okay. See, P was like this. Q was like this. Okay.
Yes, sir.
This was 30 degrees.
Yes, sir.
This was alpha, and R was there. Now you will wonder that's how you are able to recall, because these things keep on going in my mind all the time. That's what I say, that you should be able to see these things everywhere. Then your consensus start breaking. If I just bring R on this side, which is 25, then now I have equilibrium.
Equilibrium, yes, sir.
Yeah. Now you write for Q. So Q by sine, this will be 150, right?
Yes, sir.
And this will be R25 divided by sine 30 plus alpha.
Okay,
Right?
sir. Yeah,
So
right,
now you write Q, which will be 25 into sine 50 into cosec. Now you minimize it.
Okay, sir. Yeah, okay, sir.
Yeah, so minimize will give you alpha again 60 degrees.
60 degrees.
Yeah.
Okay, sir. Okay, we can also solve it that way, right?
Yes, absolutely.
Okay, sir. Thank you, sir.
Yeah.
It's all right. Good night, sir.
Good night. Grishma, do you have any other doubt? Your hand is still raised. If you have, unmute it and ask it. Okay, it seems like you don't. Okay. Thank you very much. Okay, I hope you enjoyed today's session. And okay, Kiran is there. Kiran.
Sir.
Kiran.
Sir, go to special case one, sir.
Just a second.
Sir, just we will think practically, sir. Sir, as EH member is 0, sir. Sir, but what is the use of EH in practical? Because it is not experiencing anything, sir. We can remove it, no, sir.
It is for emergency. Suppose one load is coming which is not anticipated in the design. So there will be then there will be force in that member EH. No? It is for emergency.
Oh. That's all. Thank you.
Okay. Now again I'm telling you that today truss has begun. Okay. Tomorrow you will feel comfortable because today was just beginning. Okay. We'll meet tomorrow 2 p.m. Thank you very much. Take care.